Hello, my dear JEE warriors. Welcome aboard. This is your Captain Shreyas going live on your Vedantu JEE English channel, and we are in the Flash series 2.0, which is concept plus the problems for your upcoming examination in a very crisp and concise manner. So, like you can see, there will be also tips and tricks and application of the concepts via problem solving. Okay, so this is from the scratch, but a very nice, a very different way of approaching one shot. So today's topic is all about wave optics. So right from what is a light wave to talking about Huygens principle, then moving on to interference of light, interference diffraction, then also YDSE and polarization. All these topics will be covered today. For those of you who are thinking, sir, I have not done the 11th standard waves, can I still watch this class? Yes, you can. So I have kept in mind that some students might be watching without the 11th standard topics as well. Okay, so this is the schedule for this week. You can take a screenshot. So you can see my class is there today, and then we are also going to have a gravitation class on Thursday. There will be a special class coming up on Saturday. I will let you know more about it. And on Friday, we're going to have a big marathon, probably in the afternoon, not at 11 o'clock. So most likely in the afternoon or evening. Okay, so be prepared for that as well. So let's begin with the class, and let me also remind you, in case you have not yet enrolled in the JEE crash course for the first attempt, second attempt and JEE advanced and boards, well, the crash course is still on. You can please join it. You have both the variations, crash and crash plus. Crash plus has additional personal mentorship. Other than that, it has, same things in both, be it, your assignments, be it your DPPs, be it your lectures, live classes, recordings, your notes, your tests, your mock tests, rank predictor, support for boards exam, support for NCRT, support for JEE advanced, support for JEE mains first and second attempt. Everything is included. Make sure you have studied for that as well via the crash course. And you can use my coupon code SHCC for the maximum discount, right? So let's begin with the class. I can see all of you have joined in. Hello, Ban, Nandini, welcome, welcome. Menugna, Black Caps is also here. Jyoti, hello. Arvind, hello. Revti, hello. Dushyant, hello. SSV, hello. Merugnu. Nice to see all of you out here live in this lecture. So let's begin. Starting off with what is the wave equation? Then we will go to the different types of wavefronts, and all of that slowly will progress in the chapter. When I say light wave, see, understand that any kind of wave has a wave equation. We'll talk about the wave equation first, then I will go to the light wave equation. Don't worry about it. So any wave equation, okay? So what is a wave at the end of the day? A wave, is nothing but transfer of energy. It is nothing but transfer of energy without particles going from one place to another. So it always goes from the source to the destination without particles moving from their original place, or without particles leaving their equilibrium positions. So when I talk, the sound reaches you, but the particles of air are not really coming towards you. So that is how the particles are maintaining their equilibrium positions. They might move slightly about their equilibrium positions, but they do not displace as a whole. So if you have a wave, all right, it has certain characteristics, like the maximum displacement is called as the amplitude. One particular wave length is called as the wavelength. The length of a wave is called as a wavelength, which includes a crest and a trough. You can go from crest to crest, trough to trough. All these things will be the wavelength. Even this is also the wavelength. Remember that. The time that it takes to go up and down, the time that the wave takes to go from here to here or complete one wave, is also called as the time period. T is called as the time period. These are just recollections of the 11th standard topics, or in general basics which are needed for wave optics. Like I said, I'm going to go from the scratch, correct? So this is the time period, the time taken for one complete wave. That is one complete wave, that is correct. And the inverse of the time period is called as frequency, 1 by t. is nothing but the frequency of that particular wave. The frequency, the wavelength, all of them are related to each other. So the relationships, the different relationships, and your wave equation. Let's come to that. The first one, understand, angular frequency, which is 2 pi by time period, which is also 2 pi f. This is nothing but your angular frequency of the wave. Angular frequency of the wave, right? So what is the meaning of angular frequency? Example, let's say I tell you that the time period of certain wave is 0.2 seconds. Therefore, the frequency will be 1 by 0.2. 1 by time period is frequency, which is nothing but 5 hertz. But angular frequency will be 2 pi into f, which is 5. So 2 5s are 10. So 10 pi radians per second. That means that there are 10 pi radians worth of phase in 1 second. One oscillation, one wave, one complete circular motion is always associated with 2 pi radians. If you remember even trigonometry. So when I say 10 pi radians are covered in 1 second, that means if 2 pi radians represents one oscillation, one circular motion, one revolution, one wave, so 10 pi radians will have 5 such waves. So 5 such waves are passing in 1 second. That is the meaning of this angular frequency. Similarly, you also have the term called as angular wave number, which is 2 pi by lambda, which is angular wave number, and these two are also related to each other with a formula like this. Wave speed is omega by k, which is also f into lambda. This is the wave speed. Remember that. The speed of the wave is omega by k, which is f lambda, right? I hope you remember this. So say for this example sake itself, apart from the time period, I also tell you that the wavelength is example 4 meters. Example, the wavelength is also given to you as 4 meters. Can I find the value of k? Yes. It will be 2 pi by 4. 2 pi by 4, lambda is 4. So that will be pi by 2, but the unit will be radian per meter. The unit will be nothing but radian per meter. Everybody with me? Awesome. Very nice. Now what does this tell you? Again, understand, one complete wavelength is 2 pi radians. One revolution, one circular motion, one oscillation, always 2 pi radians. So when I say radians per meter, and that is pi by 2 is 90 degree. So 90 degree is 1/4 of 360. So in 1 meter, 1/4 of the wave is there. That's what that k is telling you. And it makes sense because the wavelength is 4 meters. The wavelength is 4 meters. So one complete wave is 4 meters. So in 1 meter, you will have 1/4 of the wave or 1/4 worth of phase or radians wise. So pi by 2 radians is 1/4 of 2 pi radians. Is that entering your mind? Are you convinced with this? Have you understood this? Okay. And you can also find the wave speed. That is not a difficult task at all. Omega by k. So omega is nothing but 10 pi and k is nothing but pi by 2. Pi goes off and I will get 20 meters per second. So the speed of the wave is 20 meters per second. So I just shown you some basic examples so that you understand these terms. Let me also obviously block these results because they are obviously going to be very important in general understanding of your waves. Now when you talk about the actual wave equation, so if this is the axis along which the wave is going, and let's say somebody takes this particular axis as the y-axis, this is the origin, and maybe your wave is going something like this. With some speed v, which is nothing but omega by k. and let's say the amplitude is nothing but A, right? Then you take any random point, doesn't matter, here, doesn't matter. So you take any random point and that random point will have some y coordinate, it will have some x coordinate. That y will be a function of x as well as time. That y coordinate will be a function of x and time both. Why is it a function of two variables? Why is it a function of two variables? Because think about it, because as time moves, this point will go up and down, so it changes with time, and at any instant every x has a different value of y. So that's the reason why it depends on both the things. Okay, great. And what is that function? That function will be a sine, or you can use cos also, there is no harm in that. You can use kx minus omega t, or you can use plus omega t, or you can also use omega t plus or minus kx. Doesn't matter in what order you write it. What order you write it really doesn't matter. What matters is how you are writing it. Okay, so you can use a sine kx minus omega t, a sine omega t plus kx, a cos kx plus omega t, a cos kx minus omega t, doesn't matter. All permutation combinations you can choose. But this is the general equation of a sinusoidal wave. This is a sinusoidal wave equation. This is your sinusoidal wave equation. Keep this in mind. Correct? This is your sinusoidal wave equation. This is how it will look like. Now, how to decide whether it is plus or minus? How to decide whether it is a plus or minus? Hello, Esaki. So when it is plus, where is the wave going? When it is plus, where is the wave going? And when it is minus, where is the wave going? Doesn't matter which form you use, whether it is plus or minus decides which direction the wave is going. So if it is a minus, then the wave is going along, it is going along positive x-axis, or whichever variable is there over here. If it was y, then it will be along positive y-axis. If this was z, it will be along positive z-axis. Here it is x, so it is positive x-axis. If it is plus, then it is exactly opposite. Then it is along whatever variable is there here. So along negative x-axis. Along negative x-axis. Exactly. So it's always exactly opposite. Correct. Very nice. So we have learned the basic relationships and the basic variables which are used for waves, right? Be it amplitude, wave speed, angular wave number, angular frequency, and how a general wave equation looks like. So, my dear students, so I have put it over here. So if it is minus, you can see it is going right side. If it is going plus, then it's going left side. Standard things. Standard things. Now, when you talk about light, understand light is an electromagnetic wave. Light is an electromagnetic wave. Keep this in mind. So there are both electric fields as well as magnetic fields together in it, which make up the light wave. So say for example, the wave of electric field is like this, meaning the electric field increases, then decreases, then goes the other side, increases, then decreases, then again increases this side, then again decreases, and again increases the other side, and again. So it keeps on changing. All right. So this is how the electric field is. And let's say the wave is traveling in this direction. So what is the speed of light? So what is the speed of a light wave? So what is the speed of light wave in vacuum? In vacuum, it is basically that V is C. That C value is 3 into 10 to the power 8 meters per second. So the wave speed will be basically C, which is 3 lakh kilometers per second. Correct? All right. Very good. Very good. And the electric field, if it is like this, the magnetic field will be in the perpendicular plane. So maybe I'll have to show it something like this, like this, like this, like this, and like this. So, this is your magnetic field and this is your electric field. If you notice, the electric field and the magnetic field are perpendicular to each other. So if one were to see from this side, what you will see is the electric field oscillating up and down like this. Electric field oscillating up and down like this. And the magnetic field will be exactly perpendicular to it, oscillating like this. And the speed of light will be in or out of the plane of the board, something like that. It's going inside, electric field is going up and down, magnetic field is perpendicular to it, and the speed of light is, perpendicular to both of them. So it's an electromagnetic wave where electric magnetic fields are, perpendicular to each other and as well as to the direction in which the wave propagates. Usually we take the plane in which the electric field is contained, the plane in which the electric field is contained as the plane of light's polarization. Okay, remember, light is not just an electromagnetic wave which has this speed, but it is also a transverse wave. It's also a transverse wave, and we will see towards the end what is this polarization. But for now, just remember that this is the plane of the light's polarization. Just keep that in mind. Yes, everyone? Yep, very good. Now, if you ask me what will be the equation of the wave, then it will look something like this. The electric field will be some amplitude, just like over here, some amplitude into sine or cos, something like that. So electric field into, let's say I use sine. Then if I use kx plus minus, depends on which side it is going, omega t, then you will see the magnetic field will have a very similar equation. Magnetic field amplitude into sine. If whatever I start from here, same thing I write over here, kx plus, then plus. If it is minus, then minus, and then omega t. If it is sine, use sine. If it is cos, use cos. K, x, plus, minus, omega, t. Same order, repeat, just that instead of electric field, there will be magnetic field. Is that okay, my dear warriors? And also keep in mind one more interesting thing in these situations, that if you just divide this with this, what you get is the speed of light. E by B is E naught by B naught, because sine and sine cancels. You get C. That C itself is nothing but your F lambda. That C is nothing but your F lambda, which is also omega by K. So you can use this. Combined relationship. Yes, very nice. Also, let me tell you, this value of C can also be written down as 1 by root of mu r, or mu of that medium, and epsilon of the medium. So what is this mu m and epsilon m? These are permittivity and permeability of the medium. So that is the speed of light in any medium. That is the speed of light in any particular medium is given by this particular formula. So speed of light is 1 by mu e. Mu and e are permeability and permittivity of that particular medium. So they are nothing but permeability and permittivity. Okay, is this point clear? Is this formula clear? I have coupled a little bit of electromagnetic waves here because usually people leave electromagnetic waves. So I thought I'll play a trick on you, and I'll just simultaneously just introduce to few concepts and touch few concepts of EM waves, because it can be taught as introduction of light waves also, so that you have a clear-cut picture. Yes. So Arvind, when to take positive, negative? See where the wave is going, Arvind. If it is going on the positive side of the axis, use minus. If it is going on the negative side of the axis, is going on the negative side of the axis, then use plus. Okay, Arvind, I hope that is clear. Great. Yes, my nurture series NCERT PYQs, definitely it will help you for clearing your backlogs in the next few months, Alia. Please go ahead with that. All right. So with this, shall we start with some questions? Shall we start with some questions? All these formulas are there in your head now. Okay. So let's start with some questions coming up on your screen. Here is a beautiful question. It says there is a electromagnetic wave, means light wave, and it's going in some medium. Then what is the refractive index is what they have asked. Very interesting question. Electric field is some amplitude sine 2 pi, something is there over there. Okay. So if I want to find refractive index, think about it. What do I need? I need to find the speed. Correct? If I know the speed of the light in that medium, comparing it with speed of light in vacuum, I can get the refractive index. Okay. So how do I know the speed? I know what to do. Whenever I want to find the speed, omega by k, coefficient of time, coefficient of x. Coefficient of time is omega, coefficient of x is k. If you divide both of them, you get speed of light. You will get speed of light, exactly that. So my dear warriors, what do you think over here omega is? Omega is the coefficient of time, so it is basically 2 pi into 3 into 10 to the power 14. What do you think k is? Coefficient of x or y or whatever that variable. So it is nothing but 2 pi divided by 5 into 10 to the power minus 7. So what is the speed of the light in that medium, which is omega by k? So 2 pi, or I'll just put it over here, 2 pi into 3 into 10 to the power 14, whole thing divided by 2 pi divided by 5 into 10 to the power minus 7. What will you see? 2 pi cancels. 3 5s are 15. Okay, this will multiply. So 15 into 10 to the power, what is it? 7. So it will become 1.5 into 10 to the power 8. That is the speed of light in that particular medium. But we have been asked refractive index. So we know speed of light in any medium is speed of light in vacuum by the refractive index, standard formula from ray optics. So therefore mu will be C divided by Cm. C is 3 into 10 to the power 8 and Cm is 1.5 into 10 to the power 8. 10 to the power 8, 10 to the power 8 cancels. 3 by 1.5 is 2. So refractive index is a big fat 2. Thank you, Hemoku. Thank you so much. Yes, C is the answer. Where is C? C for Captain Shreyas. Why did you just say C? You should say Captain Shreyas is your option, which is correct. Correct? Everybody with me? Understood? Getting a hang of the wave equation, how it is. So I've given you all the theory pointers here as well as here, so that you have a brief introduction to EM waves also, and you can see it is actually a part of light waves introduction in a way. Okay, now let's talk about the actual light waves chapter, where we talk about wavefront, where we talk about direction generation using Huygens. Some questions might come at times. So let's talk about wavefront. Wavefront. Front means in the it's ahead. It's like you are an army who is standing in the front. That's like the army's front. So same thing, wave front. So one which is going ahead and ahead and ahead. So say for example, I have a light bulb over here. If I have a light bulb over here, the wave of that light will go in all the directions. The wave of the light will go in all the directions. And you will see slowly the wave goes here, goes here, goes here, etc. So what you see over here, my dear students, these circular lines that I have shown, they are basically called as your wave fronts. And these arrow marks that I have shown, they are nothing but called as the rays of your light. And one interesting thing is that wavefronts and the rays of light are always perpendicular to each other. No matter where you go, they are going to be perpendicular to each other. So I can also say that a wavefront moves with what speed, my dear warriors? Put it up in the chat box. A wavefront moves from a light source moves from the light source, moves away from a light source. At what speed? At what speed, my dear warriors? Come on, put it up in the chat box. Put it up in the chat box. Yes, at c, which is 3 into 10 to the power 8 meters per second. 3 into 10 to the power 8 meters per second in vacuum. And the wavefront moves away from the light source at this particular speed, okay, in the direction of light rays, in the direction of these light rays which I have shown, okay, the light rays, the rays of light which I have shown over here, right? So these are some things which you should know by definition. Okay, what is the meaning of wavefront, what is the meaning of light source, what is the meaning of rays of light, why are they perpendicular, and all these basic things. Correct, correct. Now, how do I make that wavefront? So Huygens gave some principles and I will explain you mainly the Huygens construction. Don't have to go through the entire theory right now, but if you want, you can go through it in NCERT. Main thing in JEE Mains is you should know how to apply it in JEE Mains. That's all. And in this limited period of time, of course, you cannot afford to go through entire things, you know, in very short duration of time. But if you want to, you can obviously go. So according to Huygens, what happens is, if you take any wavefront, it could be curved, it could be circular, it could be flat, doesn't matter. So a wavefront is generally formed, you know, by a light source. So if you have a source, you know, it could make a wavefront. A source propagates wavefronts. A source is like a disturbance. So according to Huygens, a source is like nothing but disturbance in the medium. Disturbance in the medium. He also said that this particular medium that he is referring to is called as ether, but this ether was never found. That's why his theory was discarded. Although his theory was able to explain certain phenomena like reflection, refraction, diffraction, even interference. So his theory was able to explain many theories. That's why it is still, you know, read out of interest. But as such, his hypothesis that light travels in a medium called as ether, which was never found. So because of that, it is an invalid theory. Keep that in mind. Also, apart from that, so a source creates a wavefront. Wavefront is nothing but all those points on that medium which have the same phase. So wavefront is all the points where the disturbance reaches simultaneously. So they are in the same phase. The disturbance reaches all of them together simultaneously. Keep that in mind. And what happens after that is each point on it acts like a secondary source, and then these secondary sources create secondary wavefronts. They create secondary wavefronts, and then I can say the common tangent to all of them, gives you the new wavefront. And then this process repeats, and then this process again repeats itself over here. You will see again each point on it acts like the secondary source. They generate secondary wavefronts. Then you draw a common tangent, that is your new wavefront, and on that new wavefront again each point will act like a secondary source, and this loop will continue. So this is a brief roundup of Huygens theory. Right? Now, as per him, so if you use the construction, this is how it looks like. Say for example, this is some wavefront. This is some, wavefront. This is some wavefront. And I know that light is propagating in this particular direction. This is the direction of light. So what you do is you assume each point on this, as secondary sources, and you draw a new wavefront taking them as sources. You draw a new wavefront taking them as sources, something like this. So these are your nothing but secondary wave fronts. Now what you do is draw a common tangent to all of them. This is nothing but a common tangent, you can see. So that common tangent is basically your new wave front. That is your new wave front. Is that very, very clear, my dear warriors? Is that very, very clear, my dear warriors? When the loop stops when it is absorbed. When it is, reached infinity, that is the light energy dies out. So some, medium will absorb it or some surface will absorb it. That's when the loop will stop. The light should be absorbed, obviously. Yeah, correct. Somebody also said it. Others said that it stops at infinity. In fact, there were questions on this even in JEE mains. You can see those questions. Like there was a concave mirror given something like this. How many of you have seen that question? And there is a plane wavefront. Which is coming like this. A plane wavefront which is incident onto it. How does it look after reflection was asked. How does it look after reflection? That was the question which was asked, my dear students. So how to do this kind of question is very simple. So we know wavefronts are always perpendicular to the ray diagram or the rays of light. If the incident light or wavefronts are parallel to each other, that means the rays of light are also parallel to each other. The incident rays of light are also parallel to each other. So I can definitely say the incident rays are something like this. Correct? This is how the incident rays are, because if you show perpendicular to them, you get the incident wavefronts. After reflection, what will happen? Because a parallel beam of light on a concave mirror will meet at the focus, so something like this. So they will probably go through the focus, something like this. Correct? So that's how it will look like. Now, for the reflected wavefront, just draw perpendicular to them. If you imagine a perpendicular to them, I think that perpendicular will probably look something like this. Just observe it. So something like this, then like this, then like this. And then after that, it looks like this, and like this, and then like this. You can see. Correct? Over here, you can see the wavefronts are like this, and like this. So that's how the wavefronts will look like. So depending on whether you are talking before the focus or after the focus, your answer will change. So if it was asked before the focus, then this will be the answer. If the question is after the focus, then this will be the answer. Is that making sense? So I will show the focal point very clearly over here. So this is before the focus, this is after the focus. If you understood it, give me a thumbs up, smash the like button right away, right now. If you understood it till this point, please smash the like button and put up a thumbs up in the chats. Come on, I think some of you have forgotten to give that Guru Dakshina at the start. Smash that like button right away, right now, my dear students. Yes. All right. I was born in Tamil Nadu. Who is asking that? Srivatsan. Yes, I was born. Okay. Now comes the most important part over here, which we'll talk about. That is the intensity of light. We'll talk about this. Intensity of light. intensity of light, which is basically I, is how much energy falls on it per unit time, per unit area. Hence, the unit of intensity becomes joules per second per meter square, or joules per second can be also taken as watts. So it is watt per meter square. Either this or that is one and the same thing. This is the meaning of intensity of the light. When light comes, it carries energy. So how much energy is falling per unit time, per unit area, that's the intensity. Now it so happens that this particular intensity of light is directly proportional to the square of the amplitude. Very important result, a very important result. Some people forget this, but remember, this is a common result in all the waves. Sound waves, waves on a string, light waves, electromagnetic waves, any wave, amplitude square is proportional to the intensity of the light. Another important thing which students should know is this one, that if you take a slit, okay, so this is a slit, this part is opaque, only this part is the opening, and you widen that slit, and you slightly widen that slit, something like this. So from a narrow slit, you might get some light from here. From a slightly wider slit, you will get some more light out of it. So for thin slits, remember, for thin slits, the intensity is directly proportional to the width of the slit. Keep this in mind. A very again important result. Some people think it is independent. No, this is only for thin slits, not for very wide slits. Please keep that in mind. Only for thin slits. The wider the slit is, then the intensity becomes proportional to that. Keep that in mind. Yes, brings you back to the memories of modern physics. Thank you so much, Divakar. Thank you so much, Divakar. Right. Moving on now to the next pointer. When you have a source of light and the rays of light are coming like this, if you see, when the rays go away from each other, 100% the intensity reduces. Here I can say the light is more intense, and as they go far away, I can say it is less intense. But imagine the rays of light were parallel to each other, then I would say that the intensity is just a constant. So here, no matter how you go, it doesn't matter, because this is now a parallel beam of light. How do you expect a parallel beam of light to come? Obviously, a parallel beam, rays will be parallel to each other if the source itself has a surface which emits light, which is like a plane. So if there is a plane, the light rays coming out of it will also be parallel, assuming there is no, other undesirable effects like your diffraction and scattering and all those things. So something like a sharp laser will go in a straight line. Have you used the laser torch? The green color torch, people, put it on each other and prank each other. So that is a parallel beam of light. It does not diverge anywhere. So that is how the intensity remains constant throughout. But if you have a non-parallel beam of light, obviously in such cases, intensity will not be the same. And it depends on the type of source also. So I have made a beautiful chart over here. So try to understand this. Starting off with a plane. So if you have a plane source or plane wavefront, then you will see that the wavefronts go parallel to each other. The beam of light or the rays of light are also parallel to each other. You can see that right over here. The amplitude remains constant, so is the intensity. The amplitude remains constant and so is the intensity remaining constant. Is this part clear? The part number 3? Is that part number 3 clear? Wow, Paul Dirac, thank you so much for watching the lectures from Ghana. I can assure you that there are many students from Africa who watch my classes, and I've received many messages. Some students have cleared their exams from Africa. I'm so glad that somebody from Ghana too is watching. I had students from Nigeria, South Africa, and even Mozambique watching the classes. Thank you so much. Thank you for all the love from Africa, love from India on the other side. Okay, so we have amplitude which is constant and intensity which is constant. Okay, because it does not diverge anywhere. So intensity is same for a plane wavefront, plane source of light. But there are these two other kinds of sources. One is a point source, one is a linear source. How do they look like? This example I gave you, laser beam. Plane source is laser beam. So that laser beam is a plane source. But cylindrical and spherical, well, have you seen a normal yellow color bulb? That yellow color bulb emits lights in all the directions, up, down, front, back, everywhere. So that will become like a spherical or a point source. Spherical or a point source it is called. And cylindrical, that white tube light that you get, the white tube light that you get. Have you seen that? White tube light? White tube light, yeah. So it emits light. If it's a cylindrical form, then it goes, the rays of light goes like this, like this, like this, like this. So in all the radial directions in that particular plane. So that's a cylindrical source, like a tube light. So the example of this is a tube light. Example of this is a light bulb. The example of this is a laser beam. Okay. So these are the examples so that you can not forget it. So if you have a point source, then understand the intensity is inversely proportional to square of the distance. Intensity is inversely proportional to square of the distance. These are the things which you should remember. Like for plane, it is constant. For point or spherical, it is inversely proportional to the square of the distance. And for cylindrical, it is inversely proportional to R. Inversely proportional to R. Here it is constant. Here it decreases, but not so fast, because just inversely proportional to R. Here it decreases rapidly because it spreads in all the directions. So it is inversely proportional to R square. So the examples of this is a light bulb. Light bulb. Example of this is a tube light. And example of this is a laser torch. Okay. So do not forget these things. Don't have to remember this because you know why. You know intensity is directly proportional to the square of the amplitude already. So you don't have to remember that separately. So just remember this part of the table. This is just given as additional piece of information. Even if you don't remember it, you can still solve it. So what this also means, my dear students, is that if I double the distance from a tube light, my intensity will, if I double my distance from the tube light, then my intensity will become half. My intensity will become half. Similarly, my dear warriors, if I double the distance from a point source like a light bulb, if I double the distance, so then the square of the double will become 4 times. So my intensity will become 1 by 4 times. My intensity will become 1/4 when I double the distance. It decreases more rapidly. It decreases more rapidly. I hope this is absolutely very, very clear. Let's put this knowledge to a test. Are you ready? Smash the like button in case you haven't. Subscribe to the channel in case you haven't. Starting off with this question. The amplitude of light from a point source at 5 meters from a point source is A. The amplitude of light from a point source is A at 5 meters. Then at 15 meters, what do you think is that amplitude? At 15 meters, what do you think is the amplitude, my dear warriors? Come on, think about it. You should be able to guess the answer. It's not that difficult. Figure this out. Figure this out. Think carefully. I'll give you a hint. It's a point source. And in point source, intensity is inversely proportional to the square of the distance. Not just that, also Also, I know intensity is proportional to the square of the amplitude. That is a standard result for any kind of wave. Combining both the results, what do I get? Intensity is proportional to this, intensity is proportional to this. So A square is proportional to 1 by R square. A square is proportional to 1 by R square. Take roots on both sides, you can do that, you are allowed. So A is inversely proportional to R. A is inversely proportional to R. Now come back to the original problem. From 5 meters, you have made it 15 meters. 15 meters is 3 times more. 15 meters is 3 times more. So the distance has been made 3 times. 3 times. So what will happen to the amplitude, my dear warriors? It will be 1 by 3 times. It will be 1 by 3 times. So it will be 1 by 3 times. So where is 1 by 3? I think it is there as option number A. It is there as option number A. How many of you wrote the correct answer? Very good, Shreya Kulkarni. Awesomeness. Devakar, it won't be half, it will be 1/3. Yes, Arvind, the answer is A. Okay, understood how to solve the questions based on amplitude, intensity, distance. If this was not a point source, for example, just for the sake of it, imagine it was not a point source, then let's say it was a cylindrical source. It was a cylindrical source, then I will be inversely proportional to R. But I is also proportional to A square. So A square will be proportional to 1 by R, or rather A will be proportional to 1 by root R. 1 by root R. So the proportionality will be only different. Proportionality will also be different. So if R becomes 3 times under the root, the amplitude will become 1 by root 3 times. So the answer then would have been A by root 3. The answer would have been A by root 3 if it was a cylindrical source. But here it is not cylindrical. Understand that how the values change if one small word itself changes. Very good, Kef. Excellent. Moving on now to the next main topic, which we are slowly coming towards, and that is interference. So you often argue with your parents or with your elder siblings saying that don't interfere in my work, don't interfere in my studies. So interference is exactly that, where 2 or more people or things or phenomena happen together at the same place at the same time. Like for example, your friend or your classmate is doing something in the on the bench. Then he goes away and he's done with his work, and then you come to the same place and do something. That's okay. It is an independent thing because you are not there at the same place at the same time. But if both of you come at the same place at the same time, you're like, no, I want to do this. You're like, no, I want to do this. That would be interference. So when you have a light bulb, it creates light energy. The light goes, fine, great. Then you have another light bulb. It also creates light energy that also propagates in all the directions. When these light rays meet at a certain place at the same time, then it is said to interfere. Now, because light or any such wave is made of certain quantity which changes, like in the case of light, it is electric field or magnetic field. So when these electric fields come at the same place, they might add with each other or they might cancel each other out. If they add each other out, that means they are helping each other. It's like you and your friend came at the same place at the same time and you're like, okay, let's complete this experiment or this journal. You do one thing, you do the first half, I will do the rest half. That is constructive interference. That is constructing something because that is a very good thing. You are helping each other out. Or you have to push a desk, or you have to push an almirah, you have to push a sofa. You both come at the same place, same time. Okay, I also want to push. You also have to push in the same direction. So we help each other. That is constructive interference. Is that right, my dear students? Has it ever happened with you? And if it so happens that you come at the place at the same time and your friend is like, listen, I want to push this desk over there. You're like, no, I want this desk over there. You both fight against each other. You're opposing each other. It's like 2 light waves. Electric fields are in the opposite direction at the same place at the same moment. So that will destroy each other's creativity or whatever phenomena. So that would be then called as destructive interference. Is that okay, everyone? So you are getting an idea of what is constructive, what is destructive. But is it possible that something is neither constructive nor destructive? What do you say? Is it possible for something to be neither constructive nor destructive? The answer is yes. The answer is yes. So maybe you are not perfectly opposing each other. Maybe you are not perfectly aligned together. Maybe you are at an angle. So then it would be something in between. That is called as intermediate interference or in general interference. Intermediate. It is neither constructive nor that bad as destructive, somewhere in between. That is your intermediate interference. Keep that in mind. So when two or more light waves of same frequency, no phase difference or constant phase difference, superimpose, that means they come on to each other, that is superimpose on each other, then the resultant intensity in the region, the resultant, that is the total intensity in that region, is different from the individual waves. That is your interference. Keep that in mind. So that is one thing. Now let's talk about two different types of sources, because this type of sources is very, very important for all of you. There can be a very tricky question which can be asked by just changing this word, and 100% you will lose marks if you do not know this theory. That small word can change your difference, can differ your answer. So what is the meaning of coherent and what is the meaning of incoherent? Let me give you a perfect example. Imagine there is a light wave like this, okay, and another light wave which is produced from another source or another entity like this. Or let's say there is a light wave like this, and at the same time there is another light wave which is produced from some another source, maybe like this. Or let's say there is a light wave like this, and from another entity the light wave is, let's say, like this. Okay, then let's take another example where a light wave is produced like this, and from another source it is produced or okay. Now look at all these waves, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. In all of them, you will see that there is a particular thing which is maintained or not maintained. So what is that thing which is maintained or not maintained, because of which you can categorize into two things? Look at this. The crest aligns with the crest. Trough aligns with the trough. That's enough for me. And I can be 100% sure that every other crest will come with this crest. Every other trough will come with this trough. I don't even have to bother about it. So that is predictable. I am 100% sure of what is going to happen afterwards if I know what is happening here. So that is in category 1. That is called as coherent sources. What is it called? Coherent sources. Here, this is crest, this is trough. That's enough for me to know what will happen next. Then here there is trough, there is crest. Here there is crest, there is trough. Trough, crest, trough, trough, crest. If I know at one place what is happening, I know at every other place what might happen. It's very predictable. That is again category 1. Doesn't matter, crest has to come with crest. The point is it should be predictable what might happen. That is coherent. Even over here, neither the crest comes with the trough nor the crest comes with the crest. There is a slight mismatch. There is a slight mismatch between them, but that mismatch carry forwards. That particular mismatch, which is so-called there, carries forwards throughout. So that is also predictable. whatever is the difference here is the difference here is the difference here is the difference here. So that mismatch carries forward. So again, it is coherent source. All these are basically coherent source. Point is that in coherent sources, in the coherent sources, the phase difference is basically a constant. Phase difference means in what situation they are in, the situation's difference is the same. Phase means situation. I'm in a situation, I'm in a phase, I'm in a good mood, I'm in a good phase, I'm in a good situation. That's the meaning of the phase. So the phase of these two waves are crest, 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 crest are together, and trough, trough are together. So that maintains trough, crest, crest, trough, trough, crest, crest, trough. So the difference is of crest and trough. So that is maintained. Here the difference of whatever is there somewhere in between is also maintained. So the phase difference is constant, and this can only happen if frequency and wavelength are same, but they may not be aligned. They may or may not be aligned, like I have shown over here. Okay, they may be aligned or may not be aligned, or there might be some gap between them. Is that clear, my dear warriors? Sanjay, I'm always there for you, always there for all the students. F is also from USA. Wow, we have students from Africa, we have students from USA. God knows, Sri Lanka students are also there, UAE also there, 100%. Here, there is no guarantee. Sometimes crest is there with crest, sometimes nothing is there with something, sometimes trough is there, sometimes both are not there. See over here what nonsense is happening. It's completely unpredictable. I don't like this. This is called as incoherent sources. So over here, the phase difference is not constant. The phase difference is basically not a constant, meaning I cannot be sure that if a crest comes with crest, whether the next crest will even have something or no, or the next trough will have something, or maybe the crest with it, or the trough with it, or something else. There is no surety on that. That is incoherent. Correct? Understood? It's like 5-6 singers are singing together, and they all sing in the same tone, in the same pitch, in the same frequency, the same tune. That is coherent. But like it happens in many classrooms, teacher asks 5-6 students to play for the annual function or something. One student is singing something, another student is in some sad mood. He is singing in one sad low pitch voice. Another student is very enthused, he is very happily singing. That will be a clown type of performance. It will be like a circus. Very amazing to watch. So that would be incoherent. Okay. So now coming back. Okay. Phase difference due to part difference. We are talking about only for coherent now. We are not talking about incoherent. We are talking about coherent sources. Okay. How to find what is the phase difference between them. Observe this. If there is a wave like this and there is another wave like this, you can see that there is a small gap between these two waves. There is a small, what is that? Gap between these two waves. The troughs do not come together. If they come together, good. If they are not, there is a small gap between them. That gap is called as the path difference. Path difference. And that path difference is called delta x. That path difference is called how much, my dear warriors? Delta x, or x in some books. Yes, very good, awesome. Alternating current, PYQs, we did it with capacitors, current, electricity. Just rewind back in the last week, you will see it is there in the past videos. Okay, we did it with capacitors and current, electricity. Okay, now do you remember that I also mentioned about this, that one wave that is corresponding to 1 lambda is also 2 pi radians in phase, 2 pi radians in the situation ship that we had, right? Do you remember this? No, YDSE will start after some time. We are just with interference right now. So one wavelength is 2 pi radians. So if one wavelength is 2 pi radians, how much is delta x in radians? How much is delta x in radians in that phase difference wise? Unitary method completely. So if I have 2 pi radians per wavelength, 2 pi radians for a distance of one wavelength. So for a distance of delta x, I will have a phase difference of del phi. I will have a phase difference of del phi. Completely unitary method. So this is the formula to find the phase difference. This is the formula to what? Find the phase difference. Is that clear, everyone? Awesome, awesome, awesome. Great. Now, why did we find this? The reason is because from this phase difference, you can tell what kind of interference will happen, what is the resultant amplitude, what is the resultant intensity, and every bit and piece. So for that, let me tell you one additional thing which many people do not know or do not study in their coaching. Maybe not even mentioned directly in many books. How do you know that the sources are coherent or incoherent? Let me tell you on the next slide. How do I know whether the sources are coherent or incoherent? Say for example, I take a light bulb over here. Okay, it is emitting some light, and I take another light bulb over here, and it is also emitting some light. So tell me, when these two light bulbs emit their light waves, they hit each other or interfere with each other or meet at a point, will the interference be due to coherent sources or not? Will they be due to coherent sources or not? Just answer in the chat box. Whatever you think the answer should be. And if you are joining in late, smash the like button. You can also catch up to the current topic at 2x speed or watch from this point in case you know about the previous topics. I have a feeling they won't be coherent, because even if you connect them with the same wire, doesn't matter. The emission of light process may not be continuous from both the things. Okay, they might be in the form of wavelets. So it is incoherent. Basically, whenever you have separate or independent sources, sources of light, the light coming out of it is always going to be incoherent. It is always going to be incoherent, because there is no guarantee when this bulb is emitting a light wave, this bulb will also be emitting a light wave. There is no direct relationship. There is no predictability. You cannot predict anything, right? But if it so happens that you have a single light bulb, which is emitting light, and let's say the light falls on two slits, slit number 1, slit number 2. These are two slits. The light travels in all the directions, but some of the light gets blocked. It falls on these two slits. So from slit 1, you will see that the light will spread like this, and from slit number 2, you will see, the light will spread like this. These two light sources are secondary sources according to Huygens, because they are on the wavefront of a primary source. They are secondary sources. They emit new wavefronts, one here, one here. They both, go in all the directions. They also merge, they interfere, and they produce interference results. These light waves are going to be coherent sources. They are going to be coherent sources, and these sources are then said to be, derived in nature. So whenever they are derived from the same light, so one light bulb illuminating two or more slits, those slits which are dependent on the original light bulb. Because they are dependent, they are also said to be derived from the primary. They are said to be derived from the primary. They are equally affected from the same source. That's why they are going to be coherent. They are basically derived sources. Derived, or I would say dependent. Dependent. Here they are independent, they are separate. Here they are derived, or basically they are dependent. Is that very, very clear? Is that very, very clear? Understood? Paka? Done, done, done. Let's move on to the next point. So let's do the analysis of the interference of light, because after that we are going to see constructive and destructive interference as well. So starting off with the first one, that is if it is incoherent. For incoherent light waves, for incoherent light waves that interfere, okay. So say for example, you have source number 1, you have source number 2, and both of them, they produce incoherent light waves, and finally I see that at that point P, interference occurs. That interfere at point P. The net intensity or the resultant intensity, net or resultant intensity, is given by the intensity at point P is simply put the intensity due to light 1 from source 1 plus intensity due to light coming from the source number 2. You just simply add intensities. So if there were more sources, let's say S3, and then let's say you have even more sources until Sn. So all these light waves will come over here, they will interfere, okay. Then you will have more terms over here till the nth intensity. So you just add the intensities only if they are incoherent. If they are incoherent, you just add the intensities, not the amplitudes. Don't do that. Not the amplitudes, only the intensities. Is it absolutely clear? Blacklisted gaming and others, rather than asking the question, can I crack it? I feel you should attend the classes. Rather than thinking and worrying about the future, I think it's time to act. Now it's too late to ask such questions. It's the time where you actually put into actions. If you put into actions, definitely you will be able to achieve even 99 percentile. Who can stop you from getting 99 percentile? Do not listen to anyone. Nobody has to tell you you can't. It's you who decides who will or who can get 99 percentile. So don't ask any teacher, can I do this or can I do that? You can do anything that you want. Remember, it's not me or anybody to stop you from doing anything or achieving anything. All right, this point is clear. Can we go ahead now to coherent sources? Can we now go ahead to coherent sources, my dear warriors? So when we talk about coherent sources, so this is only for coherent. The analysis is separate and mainly we deal with coherent sources only, not with incoherent. Keep that in mind. Yes. Everybody smashing the like button, smashing the subscribe button in case you have forgotten. Make sure that you smash it. Come on here, make it go up to 100 at least. What are you guys doing? Yeah. So if you have a light wave like this of amplitude A1, intensity I1, and you have another light wave like this of amplitude A2, intensity I2, they both combine together. What you get is the resultant. What you get is the resultant wave. You get the resultant amplitude and the resultant intensity. This is the resultant wave. This is the resultant wave. These are the interfering waves. Remember, these interfering waves also had some kind of path difference, delta x. From that delta x, we were able to find delta phi. Remember that formula was there. Delta phi was 2 pi by lambda into delta x. To find AR, treat them like vectors. That is something like this. AR bar is equal to A1 bar plus A2 bar. You might be wondering, how do I treat them like vectors? They are waves, they are going up and down like this. So what do I mean by that is, you take the amplitude of any one wave. If there are more waves, you just put plus 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 over here. So you take any amplitude of one wave and then take the amplitude of the other wave, but show it at an angle of del phi. That is the phase difference between them. Show it at an angle of basically del phi, which is nothing but the phase difference between them. Now these two can be treated like vectors with some angle, and then you can use your triangle parallelogram law, whatever law, your IJK rule, whatever you want, and then find the resultant, vector. That will be the resultant amplitude. So you treat the amplitudes as vectors with the phase as the angle difference between the vectors. Okay. So I think, Jayarish, I mentioned before why two light sources are not coherent in nature, because there is no surety or guarantee that when a light source is producing something, the other light source is also going to produce, a similar thing or in sync with it, because they are too independent, right? This might act independently, this might decide I'm not going to emit anything, because the light production depends on the atomic transitions, in that filament. So when the electrons jump from higher to lower orbit, then a photon is emitted. But in two independent things, there is no guarantee that transitions happen simultaneously. That's the basic reason for that. Okay, so my dear students, can I also write that the resultant amplitude will be, use the same formula which you have learnt in vectors, will be A1 square plus A2 square plus 2A1 A2, and here you have your cos del phi. That's it. So same formula you have also learnt in vectors, but this is under the root. Keep that in mind. This is all under the root. Same way, you also have a formula for the resultant intensity. But in that, the best part is there is no root except for one place. There is no big root. So it is just I1 plus I2, intensity 1 plus intensity 2 plus 2. You put a root here. There you put I1 and I2. And outside that root, you put cos del phi. So that's the formula when you have to find the resultant intensity. For any kind of interference, no matter what it is. Example, my dear students, observe this. If light of intensity, okay, 4 and amplitude 1, okay, interferes with light of amplitude 2, okay, at a path difference of, let's say, 1 meter for a wavelength of 4 meters. Find resultant amplitude and the resultant intensity. Find the resultant amplitude as well as the resultant intensity. Let's try to do this problem systematically. Everyone with me? Everyone with me? Let's write down whatever we know. Let's write down whatever we know. So for wave number 1, what is the amplitude? What is the intensity? What is the intensity? Wave number 1, the amplitude is 1. The intensity is 4 units. For wave number 2, the amplitude is 2, intensity not given. When you add both of them, you get the resultant. So here you get the resultant. I don't know this, I don't know this. I don't know this, nor I don't know this. I feel we also need to know this over here. Can somebody quickly think logically and tell me what might the intensity of the second wave could be? What might be the intensity of the second wave could be? Come on, my dear warriors. What could it be? Think carefully about it. Yes, intensity is directly proportional to, do not forget, intensity is directly proportional to amplitude's square. So if the amplitude has doubled, the intensity would have quadrupled. So it will be 4 into 4. So the missing piece over here will be 4 into 4, which is nothing but 16. Is that right? 4 times of it, quadrupled. Yes, the amplitude is 2. Here the amplitude was 1. So amplitude has doubled, intensity will be square proportional. Doubles the square is 4. So 4 times of this intensity, which is 16, my dear warriors. Yes, Shreya, very good. No, Arvinda, no, Yusuf, it is not going to be 4. It's not going to be root 2. It's going to be 16 times. Great. Now, another catch is there, and that is part difference is given, phase difference is not given. Let's try to find that out. So delta phi will be 2 pi by lambda into delta x. 2 pi by lambda into delta x. So what is lambda? Lambda is 4. What is delta x? 1. So won't it be just pi by 2? Won't it be just pi by 2 radians? I have found delta phi as well. Now let's try to find the resultant amplitude. The resultant amplitude will be root of a1 square. a1 is 1. a2 square, which is nothing but 16, plus 2 into 1 into 16 into cos pi by 2. Cos pi by 2. So cos pi by 2, this is going to be a big fat 0. Cos 90 is 0. Everybody? Cos 90 is a big fat 0. So this term vanishes. 16 square is 256. So won't it be root of 257? Won't it be root of 257? How many of you wrote the answer? Yes. Yes. Oh, sorry. I took 16, my bad. It was not intensity, it was amplitude. My bad, guys. Sorry. Let me go back. Again. You have to take these two. My bad. So AR will be root of A1 is 1, A2 is 2 plus 2 into 1 into 2 into cos pi by 2. Cos pi by 2, cos 90 is 0. So that is going to vanish. And what I will have, this whole term is 0. 2 square is 4. 1 square is 1. So 4 plus 1 is just going to be 5. So root 5 should be the answer. Just check this out. How many of you got it? Yes, Yusuf. Root 5 should be the answer. Very good, Alekhya. Awesomeness. So we got this question mark. Now let's go to the other question mark over here, which is intensity. So let's go to intensity of the resultant amplitude. So amplitude we have found. What about the resultant wave's intensity? I1 plus I2 plus 2 root I1 I2 cos phi. I1 plus I2 plus 2 root I1 I2 cos delta phi. Okay, so what is I1? I1 is 4. What is I2? Let's see, it's 16. What is 2 times of root of 4 into 16? And here we have cos again pi by 2. This is just 0, so this term vanishes. 4 plus 16, that's going to be 20, my dear students. So the resultant intensity will be 20 units. Resultant intensity will be 20 units. Is that very clear? How to solve these questions completely based out of this slide, which is interference. Okay, now let me tell you, if this same question was given, but they mentioned that it is incoherent. If they mentioned that it is incoherent, then understand, my dear students, that the intensities will just add 4 plus 16, they will just add. Coincidentally, it will come out to be 20. Don't get scared and think, sir, that time also answer came 20, this time also answer came 20. It's just by coincidence, just because the phase difference was 90. Otherwise, the answer would have been different. So when it is incoherent, you would just add this blindly without using this formula. This formula is only for coherent. For incoherent sources, you just add the intensities without worrying about the phase constants or the differences. Now, let's go to the two special cases. They are constructive and destructive interference. Observe this carefully. Now. I'm going to show a very important thing. Not many people show this to students, but I feel that you need to visualize this, else you might find some difficulty. Observe carefully now. Okay. One second. Okay, this is wave 1. Let me show wave number 2. Okay, then another situation. This is wave 1, and let's say this is wave number 2. Another situation. Oops. One second, I'll show it here. Okay. Oops, my bad. Sorry guys. Trying to draw it again. Now look at this pair, and this pair. Here, if you notice, both of them are coming together. So what is the path difference between them? Isn't it 0? Aren't they coming simultaneously? So isn't it 0 path difference? Everyone? Radical, you can watch the previous classes. You will definitely find all the previous lectures as well. And you can find the first class. It doesn't matter. These are all independent things. What will be the phase difference? Delta x is 0. Delta x into anything is also 0. So even if I use this formula which I have, 2 pi by lambda delta x is 0, delta phi is 0. So here, delta phi is also 0. Observe here, what is delta x? You will see this is exactly one wavelength. So I can see delta x is one wavelength. And if delta x is one wavelength, lambda cancels, you will get delta phi as 2 pi. You will get delta phi, the phase difference, as 2 pi. Observe here, there is one wave and then another wave. So it is basically 2 lambda. So here you will see delta x is basically 2 lambda. So delta phi will be 4 pi. Everybody with me on this? Awesomeness. So again I am using this only. If delta x is 2 lambda, lambda cancels, 2 2s are 4. So 4 pi radians, correct. Observe in everything what is saying. Crest, trough, crest, trough, trough, crest with, I think it's not fully aligned, but yeah, I was supposed to align it. Trough with trough, crest with crest, trough with trough, crest with crest. So point is that it's always interfering in such a way the crests are aligned, troughs are also aligned. Crests are aligned, troughs are also aligned. Meaning, what is it? Constructive interference. So, in general, can you say that for constructive interference, delta x will be either 0 or lambda or 2 lambda or 3 lambda or 4 lambda or 5 lambda? In general, can I say it will be n times of lambda? In general, can I say it will be n times of lambda, my dear warriors? Yep, very good. And what about the phase difference? 0, 2 pi, 4 pi, 6 pi, 8 pi, that is even multiples of pi. So that is nothing but even multiples of pi, or I can also call it 2n times of pi, one and the same thing. This 2n times of pi. So that's the condition for constructive interference. If two waves come, even if there is a lag, if that lag of the path is n times of lambda, it will ensure that the waves interfere constructively. Or the phase difference should be even multiples of pi radians. Even multiples of pi radians. Is that really understood, my dear students? Clearo, 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 clearo. Everybody with me on this? Awesomeness. Awesomeness, awesomeness. Great. Okay, just one second. One second. Yep. Okay. Now, what about the amplitudes? What about the amplitudes? Well, if this is A1, this is A2, A1 and A2 will directly add. A1 and A2, A1 and A2 will directly add. And if you notice even in this formula, what will happen? This cos of 0 will become 1. Cos 0 or 2 pi or 4 pi or any pi will become 1. It will end up being just A1 plus A2, my dear students. So I can say that the resultant amplitude, which in this case will be the maximum amplitude, will be just A1 plus A2. That's it. Nothing more, nothing less. Okay, all these are important things which you must know. Maximum possible amplitude will be addition of the amplitudes. What about the intensity? You can use little bit of arithmetic over here. You can put cos del phi as 1. You can use little bit of algebra. You can write it in a plus b whole square form. I will not go into the details right now because this is a one-shot flash marathon. So you will see that the maximum intensity will not be I1 plus I2. Don't do that. In fact, it will be root I1 plus root I2 whole square. So that is the intensity which can be maximum from two interfering waves. If you square this and expand it using a plus b whole square, you will see you will exactly get this with cos being 1. The cos value being just 1. So you will see that works out. Is this point clear? This is the condition for what? Constructive interference. This is what? For constructive interference. Very good. Similarly, you get for destructive interference, my dear students, something like this. And let's say this is like this. Okay, here you can see that both of them are together. So you will see del phi is 0 and not just del phi. In fact, we start with del x is 0 and del phi is also going to be 0. No part difference, no phase difference. Then another diagram which I can show something like this. I have to plan this properly. Okay, this will also do. Then one second. Okay, I think that's good enough. See over here, what's the difference between them? This is one wave, this is one half of a wave. So I think the path difference is lambda by 2. Observe over here, one complete wave is there and half a wave is there. One complete wave and half a wave is there. So over here, delta x is basically 3 lambda by 2. If you talk about the phase differences here, observe carefully. If you put delta x as lambda by 2, what will happen? Delta x is lambda by 2, lambda cancels, 2 cancels, del phi will become pi. So this will become pi radians. If you put it as 3 lambda by 2, then it will become 3 pi. That's all. So this will become 3 pi radians. Okay. Now actually over here, I should ideally show one more wave, because here if I start with crest, here also I should start with crest. So ignore that first diagram. Because there I did not start with crest simultaneously. This should be the first diagram, this should be the second, then I should draw the next one. If you notice, delta x is lambda by 2, delta x is 3 lambda by 2, del phi is pi, del phi is 3 pi. So from this you get an idea that your delta x must be in general odd multiples of lambda by 2. That is the first conclusion that you see. And the second conclusion that you see is the phase difference can be pi, 3 pi, 5 pi. So it is basically odd times of pi. Is that clear, my dear students? Very good. And what about the intensity? The intensity will be minimum and so will the amplitude be minimum. So the amplitude which is minimum will be A1 minus A2, but A2 could be more, A1 could be less, and amplitudes are always positive. So you always take the positive difference. And the minimum intensity, just like maximum intensity was this formula, you put this plus for maximum, you replace it with a minus sign. That's all. So it is root I1 minus root of I2, the whole thing's square. So that will give you the minimum intensity. This will give you the minimum amplitude. This is for destructive interference. Is that right, everyone? Shall we go ahead to the next point? And shall we start with some questions now? Here comes the first question up on your screen. Get ready for it. The amplitude of the interfering waves are in 2:5 ratio. Ratio of maximum to minimum intensity of the waves are. Okay, let's try to understand. The amplitudes are in 2:5 ratio. That means if A1 is, for example, x, or let's say I call it 2x, then A2 will be basically 5x. If A1 is 2x, then A2 will be 5x. That is the meaning of amplitudes are in this ratio. From this, I can find the maximum amplitude, which is just A1 plus A2. I just told that to you over here. It's just A1 plus A2. And minimum is A1 minus A2, modulus of that. So A minimum is just modulus of A1 minus A2. So it will be nothing but 2x plus 5x, which is 7x. And the minimum will be big minus small, so 5x minus 2x, which is nothing but 3x. Everybody with me? So we found the maximum amplitude as well as the minimum amplitude, 7 by 3. So a lot of you are going to mark the option A. A lot of you are going to mark the answer A, but that is not the correct answer. Be careful. That is why you should be very, very alert in the exam. Ratio of maximum to minimum intensity is asked, not amplitude. So I max by I minimum. So always the NTA people play with these words. They will ask intensity, give amplitude, or they will give intensity, find amplitude. So they play around by asking something and giving something else, and many students will fall for the trap. So this will be A max by A minimum whole square. So that will be 7x by 3x whole square. So 49 by 9, which is option number B. Understood? Clear? Yep. Yes. I hope this is very, very clear. Yes, you hope the answer is B. No problem at all. Great, great, great. Yes, very nice. Moving on to the next question. Two beams of light, I and 4I intensity, produce some pattern on the screen. Phase difference is pi by 2 at one point, 2 pi at another point. Find the difference between the resultant of the intensity at A and B. Understand the question. Two waves are interfering. At point A, this is the phase difference. At point B, 2 pi is the phase difference. So they will both interfere differently. They will both produce different intensities, resultant. The difference of their resultant is asked. So treat it like two problems separately and then find the difference. That's all. So let's start with the first part where, at point A, the phase difference is pi by 2. So the intensity at point A will be I1 plus I2 plus 2 root I1 I2 into cos del phi. So what will this be? I plus 4i, which is 5i. Cos 90 is a 0, so this term just vanishes. So that is IA. Everybody with me on this? Everybody with me on this? Cool. So let's go to intensity at point B. Remember, at point B, the phase difference is 2 pi radians. So it will be I1 plus I2 plus 2 root I1 I2 cos 2 pi. Cos 2 pi is cos 0 is 1. So this will become I plus 4i, which is 5i plus 2 into root 4 is 2. So it will become 2i again. So 2 2s are 4. 4 plus 5 is basically 9i. But that's not the question. The question is the difference is asked. So the difference is asked. So subtract these two. So IB minus IA will be 9i minus 5i, which is 4 times of I. Right? So that should be the answer. Yep, that is the correct answer. That is the correct answer. Very nice. Very nice. Awesomeness. Great. Now, a very, very unique question. Observe this. A and B are two coherent sources. Both of them are separated by a distance of 4 lambda. So the separation between them is given to be 4 lambda. You choose a point D on the x-axis and you choose a point D, detector D on the x-axis, and on the positive side exclude the points x0, x infinity. So that means you are not at B and you are not at infinity, but somewhere in between on the positive x coordinate. How many number of points will you get maximum? That means how many places will you get essentially constructive interference. Constructive interference. Let's go back to the knowledge of constructive interference, whatever we have studied. For constructive interference to happen, these are the two essential conditions. Based on these conditions, these are the two outcomes that we get for amplitude and intensity. So these are the two conditions. Out of these two conditions, let's see if we can use any of these conditions over here. I feel it's not a question about phase difference. I feel it's a question about path difference. How many of you realize that? It's not a question about phase difference. It's a question about, it's not a question about phase difference. It's a question about path difference. Everybody with me? Okay. Observe now carefully. Observe now carefully. If I choose this point A and this point B over here, okay, let's just say for the sake of it, we are very close to point B, but not at point B. X tends to 0, but not exactly equal to 0. Then I move slightly away. Like this, and the two waves reach at that point like this. Observe carefully. First, I was very close to B. Both the waves reach at this point like this. One ray here, one ray here. I move slightly away, the rays reach like that. I move slightly more away. So maybe one of the ray goes like this. The other ray has to travel like this. They meet over here. I move even far away, move far away, and they meet probably over here like this, and then I end up going very far, almost at infinity, my dear warriors, almost at infinity, my dear warriors, and they end up meeting over here like this. They end up meeting over here like this. Now think carefully, looking at this visualization, and tell me that when you basically reach almost really far, as x tends to infinity, what do you think is the difference of the lengths that these rays travel? Do you say that these rays travel equally or not equally? What do you think? Think both these rays go like that, very far away, and they meet. When you reach infinity, won't they almost travel the same distance? Can I not say this is almost equal to this? So my dear students, won't the delta x almost tend towards 0? Won't they almost travel same thing? Hence the difference will be almost 0. Very good, fun and educates. Yes, Arvind. And as you come closer, the difference becomes more and more apparent, because you can see the yellow line on the top is traveling more, the yellow line here is traveling less. As you come closer, this green line over here is like the hypotenuse. This base is obviously going to be less. When you come closer, this blue line hypotenuse from A is traveling more, whereas the blue line from B is traveling less. So the difference is increasing, and its maximum where? At point B. And when you are that close, isn't? So when x tends to 0, don't you see delta x tends towards, what's the delta x value? A travels this distance. How much is this distance? 4 lambda. B hardly travels, so won't it be almost 4 lambda? Won't it be hardly 4 lambda? Just think about it. A has to travel almost vertically down. How much distance A has to travel? 4 lambda. B does not have to travel only anything, so the difference in the lengths that they travel is 4 lambda. Everyone? Awesome. So now think about it. On this particular line that we have, at B, the path difference will be 4 lambda. At B, the path difference will be 4 lambda. At infinity, it will be 0 lambda. So in between them, what I will have? Some point with a path difference of 3 lambda, some point with a path difference of 2 lambda, some point with a path difference of 1 lambda, 0 lambda at infinity. 0 lambda is at infinity. 4 lambda is at B. But what is the question? Exclude 0 and infinity. Exclude 0 and exclude infinity. Isn't that what they have mentioned? So the only points which you have to consider is in between them. So there are 3 points where delta x is basically n lambda for constructive interference. So how many such points are there? 3 points are there. Hence answer is option A, which is 3. Hence answer is option A, which is 3. Is that clear? Yes, very good, very good. Vaki, if you can watch my old lectures of 0 to hero or 0 to superhero, there is also a video of ray optics in 15 minutes by Shreyas Sir. Just search on YouTube, ray optics 15 minutes, you will get that video. You can revise the entire chapter in 15 minutes. Second thing, watch my 0 to hero or superhero series from ray optics. I'm doing other things which were in demand, because ray optics is a very high input, medium output chapter. These chapters are medium input, high output, or low input, high output, those kind of chapters where the input is always lower and the output is higher. So those chapters have to be done in the last 20 days. If I change the question to destructive interference, understand the answer will be completely different. If instead of maxima it was minima, then guess the answer. If instead of maxima it was minima, then guess what the answer will be. So remember, for minima, what is the condition? For minima, what is the condition? 0.5 lambda, 1.5 lambda, 2.5 lambda, basically odd lambda by 2. Odd will be what? 1, 3, 5. If you put 1, 1/2 will be 0.5. If you put 3, 3/2 is 1.5. If you put 5, it will be 2.5. If you put 7, it will be 3.5. So 0.5 lambda, 1.5 lambda, 2.5 lambda. That's how it will go. So can you guess if the question said destructive interference? If the question said destructive interference, then what and all will you get? You will get 0.5 lambda. You will also get 1.5 lambda. You will also get 2.5 lambda. You will also get 3.5 lambda. So 1, 2, 3, 4. So you will get 4 minimas. If it was a minima question, you will get 4 minimas. 4 minimas, but that is not asked. I'm just adding the question or changing the scenario of the question. Yes. Awesome. Arvind, I think it will be for more 1.5 hours max, not more than that. Okay. Let's go to YDSE and its variations. Let's go to YDSE and its variations. Okay. Okay. Now YDSE is the main setup of this light waves chapter. So let's have a look at it. If you have a light source and light being emitted from it is monochromatic in nature. Mono means single, chroma means color. So monochroma means single color wavelength. We can then see multicolor also after some time. Then you will see that these light waves will travel and hit an obstacle, but there are 2 openings in that obstacle. So those are the narrow slits S1, S2. But remember, these 2 slits, this is your monochromatic light source. Monochromatic source. These are your derived sources. So that's the reason why they will be coherent in nature, and they will emit secondary wavefronts. They will interfere over here. You can see there is a screen on the other side. Why a screen? Because if they interfere constructively, that means the intensity will be good. So you will see a bright region over there. If the crest of one wave interferes with the trough of the other wave, they will interfere destructively. So you will not see any light in that region. So what happens is, because of this setup, at some places you see bright regions, some places you see dark regions. So, and these are alternate in nature. So if you start with bright, next thing you will get as you move along the screen will be a dark, and then again you will get a bright region, then dark, and then bright. So what you see on the screen is something called as the fringe pattern. Fringe pattern. You might have heard the word fringe. Fringe is like lines or bands. You draw bands, they are fringes. Okay. So fringe pattern means alternate bright, dark bands. That is what you get on the screen. That is what you basically get on the particular screen. Okay. That is your fringe pattern. Now next things which you need to know is the wavelength of the light source will be lambda. The distance between the 2 slits will be small d. The distance from the source to the screen, secondary source to the screen, will be capital D. Capital D, small d and lambda. Capital D, small d and basically lambda. Is that clear? Everybody with me? Cool. These are the main terms which you should know. This point O is also referred to as the central point on the screen. This is the central point on the screen that you obviously see. Now, if I show source number 1, source number 2, S1 and S2, and let's say from the midpoint of them, I show capital D, which is generally much larger than small d. Okay, this small d is right over here. Remember that? That is much smaller than this distance. And this is where you have your screen. This is where you have your screen. Okay, you take any random point on the screen. let's say over here, light from source 1 will go like this. Light from source number 2 will reach it like this. This is how the light rays will reach. You can see at any point on the screen, at any point P on the screen, the rays do not generally reach simultaneously except for this point which is O, except for this point which is O, where the rays will reach simultaneously. All other points there is a path difference. Did you see that? Did you see that? Yep, very good. So you will notice that there is a path difference, and that path difference is the larger minus the smaller, S2P minus S1P, but I don't know who is big, because if you go down, S1P will be large, S2P will be short. So that's the reason why we put a modulus symbol. This value, depending on where you are standing, looks like this. Let's say you are here, and let's say this angle is theta. That theta is the angular position. Theta is the angular position. Theta is the angular position. Okay. That path difference approximately comes out to be as small d sine theta. What does it come out to be? Small d sine theta. Keep this in mind. Don't go with the full derivations and all. Yeah, just remember it is small d's sine theta. Theta is the angular position. For 0, it is 0. If you go on the top, it will increase. As you go on the top, it will increase. If you go down, again it will increase. Okay, so that is d sine theta. Now, if this is only true, if and only if d is much larger than d, which is usually the case. If d is much larger, only then this approximate value works. Now, the next approximation, not many people know this. Observe this carefully. If small d much larger than lambda, meaning the distance between the slits is much higher than the wavelength. Wavelength is in Armstrong's nanometers. The distance between the slits is in millimeters. So millimeters is much larger than Armstrongs or nanometers. Then what happens? Is that the number of fringes are too many in number, like 10,000 fringes, 1 lakh fringes, bright dark, 10 lakh fringes, 5 million fringes, 100,000 fringes, like that. So when you have so many fringes, they are so close to each other, that you are not bothered about the fringes at the end. 9,58,234th fringe, I don't care. 2,052nd fringe, I don't care. 875th fringe, I don't care. What you generally care about is, where is the 5th fringe? Where is the 7th dark fringe? Where is the 1st bright fringe? Where is the 4th dark fringe? Something like that, very small order. So usually the positions that you are talking about, theta is small. Theta is small because they are more relevant for that Young's double slit experiment. This is your Young's double slit experiment, YDSE. You can see double slit. That was the reason why it is called Young's double slit experiment. So because theta is small, sine theta, can you see over here, sine theta will be theta. Sine theta will be theta. Not just that, it will be also tan theta. And if by chance I mark this as your y coordinate, the base of the triangle is capital D, and this is a right angled triangle over here. So can't you see, my dear warriors? What happens next? You will see that sine theta approximately equals theta, which is approximately tan theta. But tan theta is opposite side by adjacent side, which is y by d. So therefore, you will see delta x in many cases will be dy by capital D. That's only when theta is small. So these approximations, when what is valid, you should know. You should know. Is that really understood, my dear students? Is that really understood, my dear warriors? Very good. Very good. Awesome. Awesome. Great. Now that you understand this, you can read this later on. The bright and the dark fringes that you see on the screen, the bright and the dark fringes that you see on the screen look something like this. Observe this. You can see a bright region over here. Then you will see a dark region. Actually, I think they have flipped it. The bright has been made dark, dark has been made bright because my slide is inverted. So actually the bright should have looked dark. Okay, because when I make these dark mode slides, okay, the colors get inverted. So that's the reason for that. But otherwise, okay, this should be the bright region, then dark, bright and then dark. So you get a fringe pattern over here. You get a fringe pattern over here. And you will see that if you want to look at any bright fringe, or basically also called as a maxima, then the y coordinate of the nth fringe is given by, the y coordinate of the nth fringe is just given by nothing but n times of lambda capital D by small d. N times lambda capital D by small d. This is for your bright fringe. This is for your bright fringe. Similarly, if you are locating a dark fringe, or basically a minima, then the y coordinate of that will be given by just odd times lambda d, but here by 2. That by 2 should be there. So odd lambda d by 2d, sorry. That is for the dark fringe. If you are locating any dark fringe, this is the formula you'll use. If you are using bright fringe, this is the formula you'll use. Between bright or dark, between bright to bright or dark to dark, the distance between them is called as the fringe width. The distance between them, between any two successive bright or between any successive dark, that is called as fringe width. The symbol for that is beta. What is the symbol for that? Beta. So that fringe width is given by just lambda d by d. Lambda d by d. So because of this, you can also write this formula in terms of this beta, something like this. It will be n times of beta because lambda d by d is beta. And the dark fringe formula, you can write it as odd number times beta but by 2. This is also something which you can write down. Yes. Another thing which you should know is what is the angular width of any fringe. Very, very straightforward. So if you have any fringe having a width of beta from one bright to one bright, one dark to one dark, and you know one thing, that from the center, if you draw these lines, they will be approximately d. This angle that you see over here is called as the angular width. This is called as the angular fringe width. In terms of angle. And this looks to me like an arc. This d looks to me like a radius, and this is like the arc angle. So length of the arc is r into theta. If I use that, length of the arc is r into theta. This will be nothing but d into delta theta. d cancels. So therefore, I don't know if I have some space somewhere, maybe. Oops. Okay, I don't have space. So let me just write it down slightly over here. Just one second. So beta will be lambda d by d, and beta is like the length of that arc, which is a radius into theta. Radius is d and angle is del theta. d cancels, so del theta del theta will be how much? Lambda by d will be nothing but lambda by d. So this is another formula which you must know. This is another formula which you must know. Keep all these things in mind. This is angular fringe width. This is just your fringe width, lambda d by d. Okay, all these are very, very important. Is that clear, everyone? Now let's go to the numbering part as well. Yeah, we have done this. Okay, let's do the numbering part as well, because not many people know this numbering part and they get confused. See, wherever the rays reach simultaneously, meaning delta x is 0, that will be always called as the 0th order of interference. Whether it is constructive or destructive doesn't matter, because they reach simultaneously. That means crest and crest are coming together, crest and trough are coming together. So that's why it is also your 0th maxima. On both sides you will get maximas. Like first maxima, second maxima, third maxima. Here also first maxima, second maxima, third maxima, and so on and so forth. In between that, you will get those minimas. So this will be the first minima. Don't start with 0. Only the maxima will start with 0. So this will become your first minima. This will become your second minima. This will become your third minima. Then fourth. Same thing over here. This is your first minima. There is no 0th minima here. Please remember that. Second minima, and so on and so forth. This will be your third minima, then fourth minima, and so on and so forth. This is how the numbering happens. If you remember that in the formula for finding where that maxima is or where that minima is, you had to substitute n or that odd number. If I have to tell you the value of n, the value of n goes like this. Here the value of n is 0, then it is 1, then it is 2, then it is 3. Here it is 1, then 2, then 3. But if I have to tell you the value of the odd number, which is used over here, odd by 2, be very careful. The first minima, the odd number that you will use will be 1. That's the first odd number. Here, the next odd number, the second odd number is not 2, it is 3. So you will put 3 over here. The third odd number is 5. So that's how it goes, 1, 3, 5. So when you put odd number as 5, you get the third minima. When you put the odd number as 3, you get the second minima. When you put the odd number as 1, you get the first minima. So these numbers here talk about which odd number are we referring to. So again over here, this will be 1, this will be 3, this will be 5, next will be 7, and so on and so forth. Is this numbering scheme very, very clear? Let me know in the chat box. My dear warriors. Cool. Okay, let's probably now do some simple logical questions so that you get a hang of it. In fact, a few logical questions. This slide was not needed. Imagine I tell you that the wavelength of the light used is 400 nanometers. The distance between the screen and the slits is 2 meters. The distance between the slits themselves is, let's say, 5 or let's say 1 millimeter. Question is, find the fringe width, find the angular fringe width, also find the position of the fifth maxima, where it is, also find the y coordinate of the fourth minima. fourth minima. These are the questions. Okay, wavelength, everything is given to you. Yeah, Arvind, if you want, we'll have a small break after solving the YDSE questions. What say? After solving the YDSE questions, we'll have a small break. Okay, observe this carefully now. Okay, so first thing we can find is beta, which is very straightforward, which is lambda capital D by small d. Lambda is 400 nanometers, so 10 to the power minus 9. Capital D is 2. Small d is 1 millimeter, so 10 to the power minus 3. So what you will see, 10 to the power minus 3, 10 to the power minus 9 cancels, 10 to the power minus 6 remains. These two zeros will make it 10 to the power minus 4, and 2 4s are 8. So 8 into 10 to the power minus 4, which is 0.8 millimeters. So that's the fringe width. That's the fringe width. We can also find delta theta. Remember, I just gave the formula for delta theta. It was lambda by small d. It was nothing but lambda by small d. So it is lambda by small d. Lambda is 400 nano, that is 10 to the power minus 9. Small d is 10 to the power minus 3. So minus 6 remains, 2 zeros makes it minus 4. So 4 into 10 to the power minus 4, but this is in radians. This is in radians. Then let's go to the constructive and the destructive part. So maxima means constructive, that means bright. So the Wi-Fi maxima will be n lambda d by d, or n times of beta. Use this formula. N is 5. Beta, we just figured it out to be 0.8. We just figured it out to be 0.8 millimeters. 8 5s are 40, 1 decimal shifts. So it will become 4 millimeters. So that is the location of the fifth maxima. That's the location of the fifth maxima. Similarly, for the fourth minima, I should use odd number by 2 times of beta formula. Now, what is that beta? We just got it from here. It was 0.8 millimeters. Which odd number will you put? Which odd number will you put? Think about it. The odd number that you will put will be 1, 2, 3, 4. Which odd number? Fourth odd number. Which is the fourth odd number? 1 is the first odd number. 3 is the second odd number. 5 is the third odd number. Fourth odd number is 7. So the answer that you will put over here is 7. Correct? So 0.8 by 2 is 0.4. 7 4s are 28. So it will be nothing but 2.8 of a millimeter. That will be nothing but 2.8 of a millimeter. Is that right? Everybody? Understood? Oh, clear? Oh, Pakka? Yes. 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 Awesome. Very good, Pratham, Yusuf. Awesomeness, awesomeness, awesomeness. Great. So another question that we can solve is, what if small d is given to be, small d is given to be example, like say for example 10 times of lambda in YDSE setup. In a YDSE setup, find the number of bright and dark fringes. Find the number of bright and dark fringes. Come on, let's try to solve this. Come on, my dear students. Find the number of bright and the dark fringes. How do we solve this? Observe carefully. First of all, this is our screen. Okay. Our 2 slits are here, somewhere like this. Now, imagine you are at the origin. If you are at the origin, then your path difference is basically 0. Your path difference is basically 0. As you slowly start going over here, as you slowly start going away from the origin, you will see that the value of delta x increases as you slowly start going away from the origin, because one length is more than the other length. But when you end up reaching infinity, observe this. when you end up reaching infinity, what happens? Both these rays will almost be parallel to each other. One ray will travel more than the other ray by exactly how much amount? D amount. So won't that delta x actually tend towards D? Won't that delta x tend towards D when these rays almost meet at infinity on that screen? Are you able to visualize this? Are you able to visualize this? If so, your half the job is done. Now, understand, the path difference starts from 0 and it keeps on increasing till D. So that means in our question over here, right from here, the first path difference that I will get is 0 lambda. The first path difference that I will get is 0, or basically 0 lambda. It keeps on increasing and tends towards 10 lambda, but never actually equals 10 lambda. But what will it become is actually 9 lambda. It can become 9 lambda, but it can't become 10 lambda because 10 lambda is at infinity. Infinity is a polite way of saying never. So in between that, you will get 8 lambda, you will get 7 lambda, you will get 6 lambda, you will get 5 lambda, you will get 4 lambda, you will get 3 lambda, you will get 2 lambda, you will also get 1 lambda. And the same thing over here also. Till 9 lambda. So my dear students, count the number of maximas now. 9 over here, 9 over here, and 1 more at the center. 9 2s are 18 plus 1. 9 into 2 plus 1. How much is it? 19. So 19 maximas is what you will get. 19 maximas or bright fringes is what you will get. And talking about minimas, exactly in between that, you will start off with 0.5 lambda, then you will have 1.5 lambda, okay, and so on and so forth. And that will end at 9.5 lambda. Same thing over here below, 0.5 lambda, then you will have 1.5 lambda, and you will keep on doing the same thing in between till you reach 9.5 lambda. Count the numbers, 0.5, 1, 2, 3, I think 10 on the top, 10 below. I think this is 10 and this is 10. Correct? These are 10 minimas and 10 minimas over here. So the total number of minimas will be 10 on the top, 10 below, nothing at the center. So that will be 20. That's how you count it. 10 on the top, 10 on below. So that will be 20. Very good, my dear students. This is how you do the counting. Okay. Remember, all the 0.5s are dark. All the integral multiples are bright. That's the logic behind it. Never ever count the infinity part because infinity means never. So don't count 10 lambda up or below. That is never going to happen. Okay, cool. So these are some questions. Let's do some more questions before taking a break. Here comes the next question. YDSE slits are this much apart. D is this much. Separation between the fringes, 6th bright and 2nd dark is 4.5. Then find the wavelength. Okay. So what is the question saying? The separation between the 6th bright fringe. So Y6 maxima minus 2nd dark fringe, Y second minima. This is equal to 4.5. This is what it says. 4.5 into 10 to the power minus 3. Cool. So what is this? 6th maxima, n lambda formula. So 6 beta. This is nothing but 6 beta. 2nd minima, 2nd odd number. First odd number 1, 2nd odd number is 3. So it will be 3 by 2 beta. This will be equal to 4.5 into 10 to the power minus 3. That's the mathematical equivalent of this entire statement of the problem. Once you convert it into mathematics, it is just applying the formulas. 6 2s are 12. 12 minus 3 is 9. So 9 beta by 2 is 4.5 into 10 to the power minus 3. Very good. So what else we need? Acha, 9 by 2 and 4.5 cancels. So beta will be just 10 to the power minus 3, but beta is lambda capital D by small d, which is 10 to the power minus 3. We know D, we also know small d. So therefore, lambda will be, take small d on the top and capital D below. Capital D below is 1. Small d on the top is 0.5 10 to the power minus 3 into again 10 to the power minus 3. So it will become 0.5 into 10 to the power minus 6. If you want, you can write it as 5 into 10 to the power minus 7. But you can also write it as 3 more zeros into 10 to the power minus 10, which will then make it 5000 Armstrong if you generally like it in Armstrongs. So 5000 Armstrongs is the answer for this particular question. How many of you wrote 500 nanometers or 5000 Armstrongs? Either way, your answer is correct. Either way, your answer is correct. Very nice. Very nice. Moving on to the next one. Okay. So beautiful question. A bichromatic source. Bichroma means two wavelengths are used. So each slit will have two colors. It's like 2 times you are performing YDSE and there is an overlap. Apart from the central maxima, the maximas that will coincide, the minimas that will coincide. Okay, tell me one thing. If the fringe widths are different, if the wavelengths are different, won't the fringe width be different? Because fringe width is lambda d by d. So just imagine if one color, this is the bright, dark, bright, dark, bright, then dark, right? Like this, bright, dark, like that. If this is your 0, if this is where you start your 0 from, then that other color, maybe because it has different wavelength, that's why it has different fringe width. So maybe it is slightly longer or something like that. So it won't coincide with the next fringe. There will be a small gap over here, right? It will maintain this gap now. It will maintain this gap now. And maybe somewhere again they will overlap. Maybe somewhere again they might overlap. Who knows? I hope you understand the difference. The problem is the fringe widths are only different. Okay. So how do we solve this question? Let's start with the first one. Starting off with where the maximas will coincide. So maxima of 1 should coincide with maxima of 2. The formula for maxima is n beta, and beta is itself lambda d by d. N is different, lambda is different, because 5th fringe might coincide, 4th fringe might coincide, 3rd might coincide. So I don't know the n. Lambda is also different. D and small d are same. For the other guy, n2 will be some different fringe. Maybe 3rd fringe coincides with 5th fringe, 4th fringe coincides with 8th fringe. So those numbers could be different, and this will be d by d. dd cancels. So n1 by n2 will be lambda 2 by lambda 1, lambda 2 700, lambda 1 400, cancel. So n1 by n2 will be 7 by 4. This means the ratio of n1 and n2 will be 7:4. So ordered pairs, if you try to form, the first time they will coincide will be 7th fringe of 1 with 4th fringe of 2. 7th of 1, 4th of 2. The next ordered pair that you can get is 14, and then this is 8, and then so on and so forth. You will get many such ordered pairs. But this is the first time they coincide. That means the 7th fringe of the first one, that is 400 nanometers, coincides with 4th fringe of 700 nanometers. The second was 700. That is the first time that they coincide. Is that clear how we solved it? Is that clear? Everybody with me? Cool. Okay. What about the dark one? Do the same analysis. Y1 is equal to Y2, but for the dark, what is Y1? It is odd number 1 into by 2 into lambda 1 d by small d. This is odd number 2 by 2 lambda 2 d by small d. What you will get? Many things will get cancelled. 2 dd. So you will get odd number 1 by odd number 2 is lambda 2 by lambda 1. Lambda 2 by lambda 1 is same thing. It will be 7 by 4. Now this is the funny part about this problem. How can the ratio of two odd numbers be 7:4? It can be 7:5, 7:3, 9:5, 9:3, something like that. But how can it be 7 by 4, odd by even? Isn't this odd by even? This is basically not possible. Not possible. What does that mean? It just means that the dark never coincide. Never ever coincide. They might come close, but they never coincide. That's the interesting part. Is that clear? Isn't it a very good problem? Okay. So these kind of questions can come from YDSE. Okay. Let's see if you guys can solve this. In YDSE, the interference pattern is found to have ratio between bright and dark fringes as 9. It implies that more than one can be correct. Come on. I want everybody to answer this quickly. I want everybody to answer this really quick. Come on, my dear students. Everybody try to answer this. More than one option is correct. Think which one is correct. Yes. The two options which are correct are option B and C. Very good if you have answered it as B and C. Why? Because if you notice, the intensity between bright and dark is 9, meaning the maximum intensity upon minimum intensity ratio is 9 by 1. That intensity ratio is always proportional to the square of the amplitude. So this is A max by A minimum whole square. So A max by A minimum ratio is 3 by 1. A maximum by A minimum ratio is 3:1. But that is got nothing to do with the amplitude of the waves. In fact, A max will be A1 plus A2 and this will be A1 minus A2 will be 3 by 1. If you do componendo dividendo, you will get A1 by A2 will be 3 plus 1 by 3 minus 1, which is nothing but 4 by 2, which is 2:1. The amplitude or ratio of the individual waves, okay, I think that should be option number D, not C. I think they have marked the wrong one. This should be D, guys. Okay, ignore that. Yes, it should have been D. Okay, is that clear, everyone? Is that clear, everyone? Yes, it should be 2:1, not 3:1. And the intensities at the screen due to the two slits are 4:1. Well, that I think will be correct, because if I know A1 by A2 is 2:1, I can tell you I1 by I2 will be A1 by A2's whole square. A1 by A2 is nothing but 2 by 1 square. So that will be 4:1. So 4:1, that is also correct. So this is going to be wrong. So 4:1 and D. B and D will be the correct one. Is that right? Yes. Okay, Yashwan, for you, if physics is hard, please watch my strategy video of how to get 90 and 99 percentile. I have given a list of topics. Please do that. You will get at least 90. Okay, and watch my one shots. Okay, shall we do this after the break? Shall we do this after the break? Okay, let's have a small break for around, what's the time right now? The time right now is 8:30 almost. So break time. Meanwhile, like, and if you have not yet subscribed, please subscribe. Okay, I'll see you guys in another 10 minutes, 15 minutes. Welcome back, welcome back, welcome back. I hope I'm audible and visible. Do let me know in the chat box. That was a quick break. Not much of the lecture is remaining. Let's continue with the lecture. Remember, just before the lecture, we completed our Young's double slit experiment and some questions on that. The conditions for it, how to name it, how to find the fringe width, angular width, the position of it, the part difference, the approximations, and all those things. We just did it before the lecture. There are certain variations which we need to account for. Starting off with the first variation, which is when you get angry with YDSE and you throw it inside a liquid. Basically, the medium changes. Yes, let's grind now. Arvind, full refresh. Sir, will I keep the notes in the Telegram? Yes, the notes will be added in the Telegram. So there will be a link which will be shared. When you click on that link, that's when the PDF will open. Okay, so the link will be shared to you. Hello Yusuf, welcome back. Yes, a lot of students waiting for me. Yes, welcome aboard, my dear warriors. So let's begin with the lecture. Now, when you immerse it in another liquid, what happens is the wavelength of the light changes. And why does that happen is because lambda inside a medium is lambda by mu. Why? Because speed of light in any medium is speed of light in vacuum upon mu. Remember, the frequency is going to be the constant. So if frequency does not change, speed reduces, wavelength also reduces. And we know that since beta is lambda d by d, therefore that means the new beta prime will be beta divided by mu, because wavelength will be divided mu times, so beta will also be divided mu times. And because refractive index of any medium is more than 1, so that's why the fringe width decreases. You can see that right over here. The moment mu increases, the fringe width decreases. The maxima is still at the same place. That is kind of obvious, meaning if these were the fringes, bright, dark, bright, dark, bright, dark, then the central maxima is still at the same place, just that these will be coming closer. These will be coming closer. So you can see that the entire pattern shrinks as such. It shrinks, but the 0 still remains at 0. Okay, the total number of maxima and minimas will also increase, because if the pattern shrinks, then you will have more maximas and minimas towards the end side. That is kind of obvious. Okay, so that's the logic behind it. Let's see if you guys can solve this question which was asked in 2022. For a YDSE experiment, fringe width is given. The entire setup is placed in a liquid of 4/3 refractive index. What's the new fringe width? Guys, imagine this question was asked actually in 2022. Can you believe that? Can you believe that? It's crazy, right? Amazing. Thank you, Mervin, for all the love from Tamil Nadu. So, my dear students, over here, the idea is using the new fringe width will be the old fringe width by mu. So it is 12 divided by 4/3. 12 by 4 is 3. 3 goes on the top. So it will be 9 millimeters. So 9 millimeters should be the answer, which is option number B for IIT Bombay. You can see that right over there. Very nice. Awesome. Yes, very good. So Ashok, I have already made a video of getting 90 and 99 percentile. Please watch the video. I've given all the topics over there. Okay, it's there in the video section, not live section. Go to videos, just see 90 percentile, 99 percentile, Shreyas Sir physics. I've given the strategy for that. Now, the next variation is when you insert a slab. We also did the variation of, by the way, bichromatic source just before the break, if you remember this one. This was actually one variation. If you notice, where did it go? Right over here. Yeah. Bichromatic is also a variation of YDSE. By the way, there is one more variation which you would have also seen. What will happen if you use white light? What will happen if you use white light instead of monochromatic light source? If you use white light instead of monochromatic light source. So if you use white light instead of monochromatic light source, then what happens? White is made of hundreds and thousands of colors, right from, it's a spectrum, right from violet to red, violet, then it slowly turns violetish, indigo, then blue, then green, yellow, orange, red. All these colors are there. So each color will have a different fringe width, just like in this problem where I told you when you have two colors, the fringe widths are different. The fringe widths are different. So imagine in such a case, when you have white color, then the shortest wavelength is for violet, largest is for red. Red is the largest wavelength, okay, close to around 700 nanometers. And then you have the violet color. Then you have the violet color, which is around 400 nanometers, right? That's how it works. So if you plot it on that screen, this is how it will look like. The red will have the largest wavelength and hence the largest fringe width. So at the center, you will see red will be the largest, then orange will be slightly less, then yellow will be even less, then green will be even less, and then blue will be even less, and then the violet will be the least. This is not up to proportion, but this is how it will look like. See if you are able to see over there. This is how the color pattern will look like. And then the red will repeat after a larger distance because the fringe width is more. So the distance after which it repeats will be more. But the orange and the yellow will repeat little bit more frequently. Will repeat more frequently over here. Something maybe like this. Okay, something like this. Over here is showing some random diagram. And maybe the blues and the violets will repeat more frequently like this. So it will be like a mixed pattern. It will be like a very colorful pattern. Okay, it's only over here at the center that all the light rays will meet together simultaneously. All their bright fringes will coincide together. Here you will get white color back again if you use white color over here, because all of them are interfering constructively. You will get the maxima at 0. But all other places you will have a very colorful, unique kind of pattern, my dear warriors. So you'll have to basically visualize this. It's slightly crazy to visualize, but okay, just try to imagine this. It's going to be a little bit crazy. Some crazy colorful pattern will come. But yes, only at the center you will get the bright fringe back. Yes. Pranav, I already made a video. Okay. And Nandu, I have already made a video of how many questions will come from each chapter. Please watch that. No point asking it over here. The video is already there. 90 and 99 percentile weightage of all the chapters given with important chapters and topics to learn from. And other students, what are you guys doing? When students are asking such doubts, you should tell them, sir has already made a video. Please watch that. Concentrate on the class right now. Okay. So moving on to the next variation is where you have a slab which is put in between. Where you have a slab which is put in between. Now when you put a slab in between one of the slits, then the pattern shifts. What are the changes? Is that the pattern shifts where slab is placed, or on the side where the slab is placed. So if your slab is here, the pattern will shift on the top. If you place the slab in front of one of the slit over here, the pattern will shift below. Okay. The fringe width does not change. The fringe width is going to be the same. The fringe width is going to be the same. If it is going to be two slabs, then it is going to be a tug of war. It is going to be a tug of war. Who has more power than the other? Who has more thickness and all that? So this guy will try to shift it this way. This guy will try to shift it this way. If somehow they cancel out each other, then it will not shift at all. And the shift which is there, delta, is given by thickness into mu minus 1 capital D divided by small d. This is the shift which is produced because of a glass slab. This is the shift which is produced because of a glass slab. in the fringe pattern. So your 0 might now end up over here, 0 prime. So this is your delta. This is your delta, which is your shift. Your fringe will 0th fringe will not come here, it will come here. What is the reason for that shift? Let's understand that. See, earlier what used to happen, both the rays from both the slits used to travel the same distance to reach this particular point O on this particular screen. Both of them used to travel from the same distance, same length, okay, from S1 and S2. But imagine now you place a slab. Now you place a slab. What will happen in this part? The ray will become slower. This ray will become slower. So by the time it reaches O, there will be a lag. So S2 will reach on time, but S1 will be delayed because it has been slowed down. So both of them won't reach simultaneously at point O. In order that they reach simultaneously, that means the ray which goes through one will be slower. Because the ray which goes, ray from one goes slower because of the glass slab. So what you do, you ask that ray, okay, no problem, you're slow, you travel less distance. The other ray, which does not get slowed down, you ask him to travel more distance. So what happens is, you end up reaching a point on the top. So this ray gets slowed down over here. This particular ray gets slowed down over here, but travels less distance. This ray compensates for it by traveling more distance. So that's the reason why it shifts on the top. That's the reason why it shifts on the top. If you put the slab here, then S2 will be slowed down. So you ask S2 to go less distance, and meanwhile, because S1 is fast, you ask it to travel little bit more distance to compensate for it. Is that clear, my dear warriors? Yes. Yes. Yes, Nandu, we have all the important chapters to be covered. Great. So let's solve a question based out of that. You can see over here in 2023, 2 slabs were given, and the question was how many fringes does it shift by? Because both slabs are there, I can say that the total shift, all the data is given, this thickness, everything is given. So remember over here, this T is the thickness, mu is the refractive index, right? All those things are given to me. D is given, capital D I think is not given, but I think it's not needed also. Wavelength is given. So the shift is shift due to 1, which will be on one side, minus the shift due to 2, which will be on the other side. Each slab will shift it on either side. So you have to subtract them, don't add them, because they are in the opposite directions. Because they are in the opposite directions, correct? Now, what is the shift due to 1? It will be nothing but thickness 1 into mu 1 minus 1, capital D by D, minus thickness 2, mu 2 minus 1. I think the thickness is the same. Oh yes, thickness are the same. If thickness is the same, then why not just write it as T? No need of writing it as T1 and T2. Okay, and capital D divided by D. Now I do one more magical thing. What I do is, I divided by lambda, multiplied by lambda. The reason why I did that, you will see why. This d lambda by d will become fringe width. So it will become thickness by lambda, mu 1 minus 1, d lambda by d. This d lambda by d will become fringe width, correct? And minus, okay? This again thickness, again by lambda into mu 2 minus 1. Again that d lambda by d will just become fringe width. Okay. So now T beta by lambda is common. Here I have mu 1 minus 1 minus mu 2 plus 1. 1 cancels, mu 1 minus mu 2. So it will become thickness into mu 1 minus mu 2 into beta divided by lambda. Okay, thickness, beta, lambda. Yes, everything is there. So what is the thickness? What is the thickness? 0.1. Yes, 0.1. Okay, lambda. What is the lambda? 4000 Armstrong. So 4000 into 10 to the power minus 10. What is the beta? I don't know. Mu 1 minus mu 2 is these two differences. So 1.55 minus 1.51 and beta is as it is. So solve this. 1.55 minus 1.51 is 0.04. 0.1 into 0.04 whole thing divided by, this is 10 to the power minus 7. So 4 into 10 to the power minus 7 times beta. So this will become 4 and 4 cancels. This will become 10 to the power, just check this out. Yes. Oh, but that was 0.1 millimeter, I believe. So 0.1 into 10 to the power minus 3. So this will become basically 10 to the power minus 4 because this is 0.1 millimeter. And this will become 4 cancels, 10 to the power minus 6 by 10 to the power minus 7 times beta. So this will become 10 beta. So 10 betas means 10 fringes. It will shift by 10 fringes. That's the answer. It will shift by 10 fringes. Correct. Yep. Is that right? Everyone with me? Understood or clear? Oh? Yes, the answer is basically a 10. This was an integer type of question, numerical value kind of question which was asked in 2023. Purely calculative based. Idea was also to manipulate the formula in terms of fringe width. So when you write it in terms of fringe width, then capital D is not even needed. Capital D is not given, also not even needed. So that's how you manipulate it. Okay. Two coherent sources S1 and S2 separated by a small distance D as shown, the fringes obtained are. This was asked in 2013. Yes. I'm so glad, Sanatan. Thank you so much. Thank you so much, Sanatan. Okay, so my dear students, what do you think the answer for this will be? S1, S2 are not the traditional way. See, when that happens, it's slightly different from your traditional way over here. If S1, S2 were here, this was the screen, then this is how it goes. This is how you start seeing what the part differences are. And what you see over here on the screen are basically bright fringe here, then again bright fringe here, then again bright fringe here. You see fringe over here and bright fringe over here. This is basically your fringe pattern when S1, S2 is basically parallel to your screen. Parallel to your screen. When it is parallel to the screen. But the moment S1, S2, they are perpendicular to your screen. You can see that. S1, S2 is perpendicular to the screen, then the pattern will be slightly different. Visualize it. If you go at a point, then at that point, if you get constructive interference, you rotate that about this axis. You make this line as your axis. You will see that at all these points, a cone-like structure will be formed. You will see that you will get constructive interference. So technically what you get on the screen are not fringes, but you get rings. Fringes in the form of rings. Bright and dark alternate rings. That's what you will get. Bright and dark alternate rings. That's what you will get, my dear warriors. So it's like you take this point and you rotate it about this axis. You take this point and you rotate it about this axis. So on the screen you get rings, my dear warriors. Yes, correcto. Perfect. Let's see. Yes, you get concentric circles or rings, one and the same thing. Is that clear? So when they are parallel, you get fringes, lines like that. But when you have perpendicular, then it is concentric circles. Cool. Are you ready for the last few things, which is diffraction, and then we are going to polarization. Ready for it? Diffraction and polarization. Let's try to understand that. What is diffraction? We learned interference. We know reflection, we know refraction. What is diffraction? Diffraction is when you have light which passes through a hole, which is called as an aperture, or through a slit, that's a narrow opening, or across an obstacle like a chair or a corner, you will see that the light bends over that obstacle or that slit or that opening. That bending phenomena of light, not because of medium change. See, light bends when medium changes, that is refraction. Here medium is not changing. You can see that the light is bending, it's spreading. Okay, that is called as, diffraction. Here if you notice, there is an obstacle. Light rays were going. Ideally you should get a shadow over here, but the light rays from the side, you can see they have spread. Can you see that? There is a spread which has occurred. You can see over here also there is a spread which has occurred. So that spreading of light is diffraction. Here also the light rays ideally should have come out parallelly outside, but no, you can see that there is a spread which has occurred. That spread is basically due to the phenomena called as diffraction. Is that clear? Yes. Yes, you can definitely watch this video and do the PYQs. Now, the idea behind diffraction goes something like this. If you have an opening over here, that opening has a width of, let's say, A. The opening has a width of A. This is basically a slit. And let's have a screen over here. Okay. You can call this as D again. Okay. You will see that the beam of light which enters through this slit, that will act like mini Young's double slit experiments. Like this ray and this ray acts like a YDSE. This ray and this ray, like two slits separated by some distance. So mini YDSEs are formed in that narrow gap. Are you able to visualize? And once that happens, you will see a beautiful pattern is formed, and it is also very similar in nature as your YDSE interference. So what you see on the screen is you will get a bright region. This is your central maxima. You'll get a central maxima. It's going to be really bright. So that's why I'll show it like this. Then again, after some time, you will get the next maxima. Either on this side or that side, same thing. But that is not so bright. Width is the same almost, but it's not so bright. The next one is very faint. So it's probably little less bright over here. Next one is little faint. So this is the brightest. These one are little bit fainter, although they are maximas, but they are not as bright as other. Like in normal YDSE, what happens is if you go with the intensity, intensity is same. That's one big difference. In fact, that's a differentiating factor between Young's double slit experiment and your difference between diffraction and Young's double slit experiment. So if you talk about diffraction versus Young's double slit experiment, you will see that in Young's double slit experiment, the intensities go like this. The intensity graph looks very different, but some similarity is there. So if on this axis I show intensity, and this is your y coordinate, and this is your intensity axis, then intensity is maximum at the center for YDSE, goes to minima at dark fringe, again maxima, again minima, again maxima. So maxima, minima, maxima, minima, maxima, minima. So you can see all of them are on that same line. All the maximas have the same intensity. But in case of diffraction, you will see it is something like this. That's it. So the most prominent one is the first maxima. After that, rest of the things are hardly seen. Rest of the things are hardly seen. So this is the most prominent one. Is that okay, everyone? Clear till this point? One big difference between the intensity parts. Okay? Between the intensity parts. Keep that in mind. Yes. Okay. Now moving back. Because they are not so visible, usually what you find is where the first minima occurs. Usually what you find is where the first minima occurs. This is where your first minima occurs. This is where your first minima occurs. This is where your first minima occurs. And that angle, if I call it as theta 1 here or theta 1 over here, that theta 1 is the angular position of the first minima of what, guys? Diffraction. Of diffraction. And the formula is as follows. It is A, remember A is the slit width, into sine theta 1 is basically lambda. A into sine theta 1 is basically lambda, or you can also call it as sine theta 1 is a lambda by A. Sine theta 1 is basically what? Lambda by A. Is this part clear? Now, when theta is small, when your theta is basically small, then sine theta will be theta. So can I say theta 1 approximately is lambda by A only when sine theta is small? Otherwise, you cannot use this particular approximation. And not just that, theta 1 will also be equal to tan theta 1 approximately. Will be approximately tan theta 1. Keep that in mind. Now, if you look at the, actually, see what I have done is maxima will be over here, but slowly the intensity will go out, right? Slowly the intensity will fade out. Intensity will be maximum here, and then slowly the intensity will fade out. So this is how it will look like. So I've shown it as if it is uniform, but actually this is how the fringes are. It is bright over here and then it becomes faded out. This is how it is. Correct? Something like that. So if you look at the central fringe, it has some width. If you look at the central fringe, it has some width. I can call it as, let's say, W. I can call it as W. Correct? And I can find that width using simple trigonometry. I'll tell you how. If you look at this triangle, this is 90 degree. Opposite side by adjacent side is tan theta. What is the opposite side? What is the opposite side, my dear warriors? The opposite side is nothing but W by 2. Opposite side is nothing but W by 2. W is the width of it. W by 2. Everybody with me? Everybody with me? Yes. Very good. Upon adjacent side is nothing but D is equal to lambda by A. Rearranging the term, I will get W is nothing but 2 times lambda capital D by A. This is the width of the central maxima. This is the width of central maxima. Keep that in mind. Width of the central maxima. Is that clear, my dear warriors? Is that clear, my dear warriors? So you will get a diffraction pattern where the first minima is what is most important, because the other minimas and maximas are hardly seen by you. So mainly concentrate on the first minima, because the later on minimas, even if I write A sine theta is n lambda, A sine theta is n lambda, this is for the first one. Those are not so relevant, nor are the maximas, because they are not so prominent. But still, if you want, I have given you the formula for that. Now, what is very important is many students do not understand this equation and when diffraction occurs and when diffraction doesn't occur. So observe this 3 cases. Observe these 3 cases. First case, let's say lambda is more than A. Second case, lambda is equal to A. And the third case, lambda is less than A. Lambda more than A, lambda less than A, lambda equal to A. All the three cases. So here A is more, here width is slightly less, and here it is the least. This is the width of the slit. Okay. Now comes the interesting part. Observe this carefully. What was the sine theta for the first minima? That is the angular position sine for the first minima. From that I know how much is that central maxima wide. How wide is that central maxima? Sine theta is lambda by A. Sine theta is lambda by A. We just figured that out over here. So sine theta 1 is lambda by A. So in this case, my dear warriors, think about it. Since lambda is more than A, sine theta 1 will be more than 1. Think about it. Because lambda is more than A, numerator more than denominator, sine theta is more than 1. Keep that in mind. Here lambda is A, so sine theta 1 is 1. Here sine theta 1 is less than 1 because lambda is less than A, numerator less than denominator. When this happens, that's okay. Trigonometric ratio sine theta should always be less than 1. Should always be less than 1. Everyone? Sri Chandana, I have already mentioned the weightages in a separate video, my dear student. Okay, there is a video. You can just check it out. I'll show you later on. Okay, if you want, but there is a separate video. Okay, right. Now, this is possible. That means what will happen is the light will be bright over here. We'll get a bright fringe over here, maybe something like this. And then after some time, maybe you'll get a smaller peak somewhere over here. And then the peaks are very less relevant. This is how it will look like, correct? This is how it will look like. You will see this is very, very weak. Main thing is this one. Main thing is this one. And you will see that almost most of the light is going like this, 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 like this. So it is spreading here, hardly any light is spreading here. When theta 1 is 1, that means the first minima is at infinity, 90 degrees, 90 degrees. Think about it. What does this mean? Theta 1 is 90 degrees. So the fringe pattern is really wide. It is really wide like this. It is really, 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 really wide. Something like this. It is really wide. So what it also means, yes, light went here, here and here, but it kept on spreading almost till infinity. Almost everywhere the light has spread. Almost literally everywhere the light has spread. More spreading has occurred. Here sine theta is more than 1. It is not possible only. It is not possible. Not possible. That means no diffraction. No diffraction. No diffraction occurs. And in such a case, what happens is you will see the light rays will just go and form a bright spot over here. No bending occurs. No diffraction occurs. That's what will happen. It just goes straight. Nothing. No diffraction only. So that's why they say if the wavelength is smaller or equal to the width of the slit or the obstruction, that's when diffraction is more. But if the wavelength is more, then the diffraction is not there. Did you understand the logic behind it? Did you understand the logic behind it? Sai, more few minutes, that's all. We are come to the end of diffraction after this polarization. Keep this in mind. Okay, so all these things are important. Let's see if you guys can solve this particular question coming up on your screen. Consider the diffraction pattern obtained by sunlight on a pinhole of some diameter. If the diameter is slowly increased, what do you think will happen to the diffraction? If you increase the hole, then more light will come through that hole, so intensity will increase. And what happens when you increase the slit width? What happens when you increase the slit width? We just did that over here. If you increase the slit width, you can see that over here. If it's small, wider, you can see earlier it was spreading more, now it's spreading less. Come on, my dear students, what do you think should happen? The size should decrease. The size should decrease. You can see that right over here in this particular question. Lambda was A, lambda is made much smaller than A, right? So this is what will happen. If you make it slightly wider, you will see that the width will decrease. Here the width was more. As you make A and A larger, if you make this width larger, you will see it will go down like this, right? That's what will happen. Is that right? So that's why the answer is decreases, but the intensity will go up. Cool. Shall we go ahead? Okay. Okay. Great. All right. Everyone with me, shall we go ahead? All right. I can see a lot of Telugu students. Please let me know if you want me to start something for EM Stat on the channel. Okay. After mains, I'll be definitely planning to do something. And if you want me to do that, and that too in English, I want your full support, okay, on this channel. Do let me know, okay? All the Telugu babus and yeah, all the girls out here and boys out here, yeah, please let me know. Cool. Now let's go to the last part, and that is polarization. Very simple phenomena. So light is a transverse wave, and a characteristic of a transverse wave is that it can be polarized, all right, and a longitudinal wave like sound cannot be polarized. So what is the meaning of that? Let's understand it by a simple visualization. So imagine light is an electromagnetic wave. You can see the blue part is electric field, the red part is magnetic field, something like that, okay? Or let's say there is light coming, and some of the light has electric field oscillating in this direction, some light has electric field oscillating in this direction, some light has electric field oscillating in this direction. And imagine there is some mechanism which is called as a polarizer, which only permits electric fields to pass which are in a particular direction. What do? They only permit electric fields which are in a peculiar direction. So any electric field component which is perpendicular to the slits, that are eliminated. So if an electric field like the red one is there, it will not pass, it will not come out of it. Only the fields which are in this vertical direction will come out. So that is the meaning of this word polarization. This can only happen with perpendicular oscillations. If it was sound, the sound waves will go oscillate in and out, whether it is whether this particular polarizer is held like that or like this doesn't matter, because the particles of sound will just go in and out, they will naturally pass. But if I take this polarizer and tilt it like this, then instead of the blue wave coming out, the red wave will come out. So if I tilt it by 90 degrees, you can visualize the blue part will get eliminated and the red part will come out. So this is the effect of polarization, and it can only happen with transverse waves. Is that right? Everybody with me on this? Now, usually the light that you get from the sun is unpolarized in nature. So you will have one light wave having like this kind of a plane, another light wave, having in different plane, okay, maybe something like this, another in a different plane, another in some completely different plane. So basically one light might be oscillating like this, the electric field, another light might be oscillating like this, another light might be oscillating like this, another light might be oscillating like this. So many different oscillations are possible, and if you combine all of them together, you can see in sunlight or even a light from the bulb, they have oscillations in all possible planes. And when such things happen, that is called as unpolarized light. Unpolarized light. Unpolarized light, because the field oscillations are in all the different directions. the field oscillations are in all the possible directions. So what is this arrow mark representing, my dear students? Is the electric field oscillations, electric field oscillation plane, electric field oscillation plane of that particular light. Because here it is in all directions, it is said to be unpolarized light. But on the other side, if you have polarized light, if you have polarized light, the polarized light has oscillation only in one unique direction, either this or something else. It could be either this, or it could be like this, or it is not and, it could be any of these kind of directions, or it could be like this. This is basically your polarized light. Usually the light which comes from the sun, so I can put examples, light from the sun or the bulb or other sources like that, like the tube light, they are all unpolarized in nature. So can I make unpolarized polarized? Can I make polarized change its plane? The answer is yes. And that is given by Malus law. Whose law? Malus law. So Malus law is able to tell you how to change the plane of oscillation, or if you have unpolarized light, can you make it polarized? So say for example, you have a polarizer, something like this. You have this is called as a polarizer. Usually it is some organic compound or some crystal or some solid which has some dielectric and permeable, dielectric and magnetic properties which are aligned in a peculiar direction. So let's say for example, the plane in which the polarizer allows the oscillations to pass through it is like this. The plane or the direction along which the polarizer allows the oscillations to pass is like this. Now just imagine you have a light wave which is completely unpolarized, something like this. Observe this. It's like this, and that light happens to enter into this polarizer. So what will happen? What will happen if such an unpolarized light, this you can see is 100% unpolarized light, is entering through this polarizer? You will see all the components of the electric field which are perpendicular will get cancelled out. They will not be allowed. Only certain components will come out of it. Only certain components will come out of it. So you will see the final light will have plane of polarization in the plane of the polarizer, So all the other components got eliminated. In fact, if you see, if the intensity of the light over here was I, if the intensity of the light over here for unpolarized light was I, and this is your polarized light, you will see exactly half the components, because every oscillation has x and y, x and y, x and y. X and y are equal in amounts. All the x got cancelled, only y remained. Since x components and y components are equal in amount and all the x components got eliminated, only the y components came out of it. So the intensity of the light which comes out will be I by 2. The intensity of the light which comes out will be how much, my dear warriors? I by 2. So that's how you get unpolarized light make into polarized light. So that's how you get polarized from unpolarized. Now once your light is polarized, once your light is, let's say, polarized, so this is your polarized light, let's say of intensity I, and you make this light go through a polarizer, but that polarizer is itself at an angle. That is the crazy part. The polarizer itself is at an angle, something like this. Okay, so the angle which is made is something like this, and the light ends up going inside over here like that, and the plane of the light and the plane of the polarizer, the plane of the light and the plane of the polarizer are inclined with each other at an angle theta. Are inclined with each other at what angle, my dear warriors? Theta. Then only a component of it will pass through. Only a component of it will pass through. So what comes out of this? What comes out of this will also be polarized, but it will be exactly parallel to these yellow strips that I have drawn, basically to the polarizer. So you will see it will be also at an angle over here, and this intensity will be I cos square theta. This is called as Malus law. This is called as Malus law. Okay, keep this in mind. So Malus law says that if you have a polarizer which is at an angle with the polarized light, then the intensity of the light which comes out is the original intensity into cos square theta, where theta is the angle between the plane of the light and the polarizer. Is that clear, my dear warriors? Yes, awesome. Now that you understand it till this point, the final aspect over here is Brewster's law. The final aspect over here is Brewster's law. It says that if you have, let's say, air and this is some medium, if you have air and some medium, let's say light falls on that medium, some of it gets reflected, some of it gets refracted. You make the light go at another angle, it will get reflected at another angle, and it will bend at another angle. You make that light go at another angle, it will get reflected at another angle, and part of it will get refracted over here. So remember, this part is the incident part, this part is the incident part, this part is the reflected part, and this part is nothing but the refracted part. It so happens that if you pass unpolarized light and you see what has happened to the refracted and the reflected rays, you will see the reflected ray is partially getting polarized. There will be partial polarization for the reflected rays, and when this angle is 90 degree, that is the reflected and the refracted rays are at 90 degree, and you pass unpolarized light and you see the reflected ray, it will be completely polarized. This is Brewster's law. This is your Brewster's law, correct? So when the reflected and the refracted rays are perpendicular, the unpolarized light which falls on that medium gets completely polarized. And we can call that angle IB. That IB is called as Brewster's angle of incidence. Brewster's angle of incidence, and that's when refracted ray is perpendicular to reflected ray. And this happens when tan of IB is equal to mu. Tan of IB is equal to mu. That is the formula. The tan of the angle of incidence is the refractive index. That's the idea of this. Bhavya, you can watch my old kinematics one-shot videos. I'll just show it to you also. Okay, so this is what I have also mentioned on this slide. If unpolarized light falls at the Brewster's angle, the reflected ray and refracted ray are perpendicular. You can see the plane of oscillations are in both the directions, inside out and like this, but the reflected ray becomes polarized in one direction only at that angle. Otherwise it is partially polarized. Okay, some of it gets polarized, not all of it. That's the meaning of it. Meanwhile, let me also show you that many students are asking, sir, where is that strategy video? Look at this. I have made this strategy video. First is that motivation. If you need that motivation, watch this particular motivation. I have made a very short 2 minutes motivation. You can see get 99 percentile in JEE Mains, 6 topics for 90, 10 topics for 99 percentile is already there over here. You can watch this particular video. For physics, you have chemistry and maths also. And if you want the other strategy for how to get 99 percentile, the books, it's in the live section. You can also see that long time back I had also given the final target for 99 percentile and how to exactly achieve that 99 percentile over here. Okay, and meanwhile you can always search for any topic. Let's say for example kinematics. You want to search for kinematics, just search for kinematics Shreyas on this particular channel. You will see 1D kinematics videos are there. You can also see Zero to Hero series is also there. So you can see JEE Crash is also there. You can watch these lectures. Similarly, if you want to watch a ray optics, just type ray optics and just type Shreyas. That's it. Just type Shreyas. You will see ray optics. Zero to Superhero series is also there. Your ray optics and in 35 minutes is also there. Okay, ray optics for special topics in detail also is there. So all these things are there on the channel. It's just about how much you explore. How much you explore. So let's have a look at the final few questions coming up on your screen, my dear warriors. If unpolarized light is incident on the surface at Brewster's angle, which one of the following is true? Which one of the following is true? Sri Chandana, I just told you the weightage class, the 10 topics for 99 percentile, 6 topics for 90 percentile. I have made the complete weightage. Watch that lecture, Sri Chandana, okay? Wave optics also have given in that session, that video. You please check it out. You're asking the same questions again and again, but it's there on the video. You guys are not seeing that video. Yeah, see that video, okay? So my dear students, what is the answer? If it is on the medium, it is unpolarized and it is at Brewster's angle, then the intensity is less than I0 by 2. Okay, it gets polarized completely and it's not exactly half and half. It's not like half the light gets refracted, half the light gets reflected, or less than half gets reflected, more of it gets refracted. So that's what happens at Brewster's angle. Okay, cool. Let's move on to the next one coming up on your screen. A beam of unpolarized light, my dear students, is falling at intensity I0, pass through a Polaroid A and then through another polarizer B, which is oriented such that it is making 45 degrees relative to A. Intensity of the light is unpolarized light. So okay, so this is our unpolarized light. This is our unpolarized light. This is how it will be. It is having an intensity of I0. It is passed through a Polaroid A. It is passed through a basically Polaroid A. So this is our Polaroid A. Okay. Then what will happen? After it passes through A, it becomes polarized. So only some of the light, in fact half of the light will pass through it. So it will become I0 by 2. Now another Polaroid B is oriented so that the principal plane makes 45 degrees relative to that of A. So that means the next one is probably like this at an angle. It is making 45 degrees. So what will happen to the intensity? Whatever intensity fell onto it, I0 by 2, that intensity is cos square 45 will come out. So it will be I0 by 2. Cos 45 is 1 by root 2 square. So it will be I0 by 4. I0 by 4 is option B. I0 by 4 is option B. Yes, that's the correct answer. Not D. Many of you made a mistake. Lakshman, I think. It's not going to be I0. Be careful. It's cos 45, which is 1 by root 2 square at 1 by 2. Again multiply by 1 by 2, which will make it I0 by 4. So unpolarized became polarized. First stage. Second stage, by that Polaroid B, which was already at an angle, 45 degree. So a part of this light will come out, again polarized at a different angle. So that's the idea behind this. Okay, so that was the last question, I believe. So this was your Captain Shreyas. That's my, credentials. Make sure you smash the like button and also subscribe for your captain. And if you want EMSAT and other such exam preparation, that's something which you want, then make sure you put it up in the comments. And I want all the crowd, subscribing to the channel and posting it in huge numbers and liking those comments also. Obviously, the physics formula revision will follow in the days to come. We'll have one more class, and that's gravitation, which is low weightage but high output. So if you have watched the video till the end, make sure you put up wave optics done. Wave optics done, yes, in the comment section, so that I know you have watched the class. Okay, I want to read all your comments. I'll be going through all your comments after the session is over. Even if you're watching it recorded, still put it up. It will make me feel very happy. Show your love, show your support with like as well as subscribe. Thank you so much. Thank you for tuning in till the end. Bye bye. Have a great time. And we will again meet for gravitation and then physics formula revision and mock test and so much more. Stay tuned on the channel. Bye bye. Captain Shreyas signing off. Hasta la vista.